Uh, so today we will continue with the revision session on database management systems and also data warehousing for DS students. As we know, the syllabus is divided into three parts called database design, implementation, maintenance. In database design, we have ER models, relational models, then schema refinement. We call functional dependency and normalization. And in the implementation, we have seen relational algebra and calculus and structured query language, SQL. And in a database maintenance, we have seen transaction management and concurrency control and recovery management and file organization and indexing. And for DA people, we have a data warehouse. Fine. So, we are going to discuss, we are going to review all the topics, and my discussion is according to the concepts through questions. Okay. And moreover, during the session, if you have any doubts, and you can feel free, post your doubts in the Q&A, like in webinar chat, so I can see your chat parallelly, so that I can read your doubts and I can explain you parallelly if anything is required. Okay. The syllabus is common for data science and artificial intelligence and computer science people, and the topics of transactions and recovery is not there for DA people, it is only for CS people, that you know, and data warehouse is only for DA people. I am going to revise all the concepts in briefly and will go ahead with questions. So, through questions I am going to revise the topics. Okay, this is about weightage analysis. Then when comes to the first topic, entity relationship data model, and moreover, just I want to know, I think it is audible, right? Is it audible? Yeah. First, we'll go ahead with the entity relationship data model. When you see ER models, what kind of questions were asked? In ER models, they have asked on ER notations. The questions on ER notations. This is the first thing. Questions on ER notations. What is entity, relationship, attributes, that notations of that attributes, like a multi-valued attributes is to be represented with a double ellipse, and ER notations. Last GATE exam, I think in 2021, they have asked how do you represent the weak relationship. The weak relationship is to be represented with double diamond. So, the ER notations is important. Just when it comes to the ER notations, like what is expected is called composite attributes, like how composite attribute is to be represented, attribute with attributes. This is a composite attribute. When it comes to the multi-valued attributes, we call double ellipse, and when it comes to the derived attribute, it is called dotted ellipse. The special notations I am showing you, and we have a partial key. Partial key is attribute with dotted underline, and a weak relationship is double diamond. Weak entity set is double rectangle. Weak entity set is double rectangle, and any special notations, hierarchical relationship, it is to be shown with is a, right. These are the some of the special notations, and generally instead of going with regular notations like entity relationship and all. So, you may expect this kind of notations. What is the symbol? Which symbol will be used to this one? It could be 1 mark question. This is ER notations. And then You may be asked to give some scenario, uh, second thing type of question. What you can expect is, you will be given a scenario. Scenario means some case study is given, and based on that case study, you have to draw ER model. This is expected type. I am telling you, this is expected type. And these kind of expected questions, I have included some of them in your test series. And draw ER notations, draw the ER model. And on ER model, you will be asked some questions like there is a partial participation, total participation, key constraints, cardinality ratios, and on conversion of that ER model, like how many tables are possible. These kind of questions are expected to be asked, and that kind of expected questions I have given included in your test series. Fine, this is expected. And third thing, you can expect questions on cardinality ratios. It is cardinality ratios. And parallelly, you may expect questions on conversion of ER models to relational models, and ask to find minimum number of tables. And ask to find minimum number of tables. And minimum number of tables is the old type of questions. But questions may be in a different way, like minimum table, maximum tables, like if this table combined with that table, what is going to be primary key, foreign key, that kind of way of asking questions may be different. Okay. So, we will discuss, I am going to revise the ER models topic with respect to some questions. I suggest you people to answer the question through chat box or Q&A. If possible, I will give a poll also. Now, look at this question, how the question was asked, and I am going to revise the topic through questions. Just have a look. Yeah, here, what is the question? The question is, suppose is part of, is a relationship type with two participating entity types, district and state. Okay. So, is part of is a relationship, is part of is a relationship between the two entity types we call district and state. District and state. Okay. Now, question is, what is a cardinality? What is the appropriate cardinality ratio for district and state? Now, what is appropriate cardinality ratio between the district and state? Like each state, like simple, each state can have how many districts? Each state will have many districts. So, many you write to the district side, and each district belongs to how many states? One state. So, what is the cardinality? Many to one. So, what is the majority people have selected? Option C, perfect. Okay. Now, this is about cardinality. We have four types of cardinality: one to one, one to many to one, many to many. How you have to write the cardinality for a particular scenario? Simple. Say here, what is the possibility? Each district belongs to one state. So, you write one at the state side. Each state belongs to, each state can have many districts. So, district side you write many. So, it is called many to one. So, accordingly you have to write the cardinality, means an entity of a side associating with how many entities of other side, maximum possibilities. That maximum number you write in the other side. Like each state, this entity, it is associating with how many entities of other side, you write in this side, so that you can define the cardinality for that scenario. This is about cardinality ratios. I'll give you one more question. This is slightly different. Just read the question and try to understand the question. I'm giving the poll for you. Read the question carefully and answer. I'll give you 1 minute time for understanding and answering the question. So, sorry, yeah, voice was muted, mic was muted. So, what is given? Assigned is a relationship. It is mentioned, it is many to one, with two participating entity types, employee and department. Employee in the one side, department in the other side. between the employee and department, it is mentioned cardinality is many to one. Okay. Do you remember if it is many to one, we have a key constraint. Now, key constraint is from which side? Which side? In many side. As I have discussed, if it is one to one cardinality, we have a both side arrow, correct? Do remember? And if it is one to many and many to one, we have a arrow from many side arrow. And if it is many to many, any key constraint possible? No key constraint possible. And these are the points we have discussed. Okay. So now if it is many to many means we have an arrow from employee to assigned. And what is the meaning of arrow? I am revising every point. What is the meaning of arrow? The meaning of arrow is called at most one. And what is the meaning of double line and arrow? Tell me, what is the meaning of double line and arrow? You can answer through chat. I will check. Okay, what is the meaning of double line and arrow? It is called exactly one. What is the meaning of single line? It is called 0 or many. Right? What is the meaning of double line? At least one. Fine. These are the notations that we have discussed. Fine. Now, what is mentioned up to this question? The cardinality is many to one. So that employee side arrow is possible. Fine. Look at a maximum of 7 employees are assigned to a department. Maximum of 7 employees are assigned to department. Means to one department, how many employees are assigned? Maximum of 7. Okay. Maximum of 7. To one department, how many employees are assigned? Maximum of 7. That is mentioned. Okay. And both are participating totally in the relationship. So we call total participation. So total participation is represented with double line. Here also double line. And here you observe that many value is 7. Means each department, in the previous question I also have explained, each department assigned how many employees? 7 employees. And anyhow it is mentioned many to one cardinality, means each employee assigned to how many departments? One department. That is the meaning of it. Okay. If in the ER diagram, the line that connects employee to the relationship, okay, this line, employee to the relationship, type assigned is to be labeled with x comma y using min-max notation. Choose the correct option. What does it mean? Employee is connected with minimum how many assigned relationships and maximum how many relationships. This one you can answer it simply. From employee to assigned, what notation is there? Double line and arrow. Double line arrow. What is a double and arrow? Is called exactly one. Exactly one means minimum how many? 1. Maximum how many? 1. Correct? Minimum 1, maximum 1. It means one employee can participate with minimum 1 relationship and maximum 1 relationship, because double line and arrow is saying that it is exactly 1. So it is 1 to 1. Now minimum is 1, maximum is 1. That is an option B. Oh, very few students answered this question. That's why I thought of discussing it. Okay, now I will ask you, just you can answer in the Q&A. Now, what is the minimum and maximum from department to assigned? Just take a minute of time and try to answer it. Try to answer it. Answer in the Q&A. Here, each department, because it is a total participation. Total participation says what? At least 1. That double line says at least 1. So minimum 1. Maximum already mentioned 7. Finish. This is 1 7. Perfect. Divya, Polakam, Buddy Reddy, very good, all of you. So I hope you understood now how to answer this kind of questions, because majority of the students are posing the same questions. Even now, before me answer the question, I have seen in the poll, majority students have selected option C, but option C is wrong. That option B is right. Okay. Chalo. What is the correct notation for the above ER diagram? This could be a multiple selection question. Go ahead. Fine. So, just 1 minute for the question. What is the correct notation for the above ER diagram? Just now I have told you what is the meaning of notations. This is called single line and arrow. Single line and arrow is called at most one, and double line is called at least one, right? And single line is called partial participation, double line is called total participation. Okay, question is about participations. Partial participation of E2 in R, but E2 we have total participation, and single line is called partial participation. So, partial participation of E2 is wrong, total participation of E2 is right, and total participation of E1 is wrong, and key constraint from E1 to R is correct because it is an arrow, arrow is called key constraint. So, there is both B and D. Okay, perfect. Nice. This is a simple matching kind of questions. Consider the following sets and match the following set C with set D and answer it. This is because, as I told you, the questions are possible on notations. Na? So, which one will be the notations for which concept in ER model? That kind of question I have included by giving a match the following. Okay, go ahead with this question. Here it is for match the following weak entity set. How weak entity is to be represented? Double rectangle box, right? Multi-valued attribute, double ellipse. Derived attribute, dotted ellipse, right? Derived attribute is dotted ellipse, and relationship is diamond box. These notations you need to know. And weak entity set is to be represented with double line rectangle, P matching with Y. So, P matching with Y, it means that A and D are wrong, and multi-valued attribute, it is to be represented with double line ellipse. So, Q matching with Z. So, in both of that, Q is matching with Z, and derived attribute is to be represented with the dotted or dashed line ellipse, that R is matching with the W. So, that B is wrong and C is correct. Perfect. Majority students have selected, but again I am seeing few mistakes from students. Please don't do that. Here I am sharing the results also. If you want, you can check it, how many of you answered correctly, right? And these are the kind of questions possible exclusively from the ER models, exclusively from the ER models, right? What kind of notations, and mostly on cardinalities, you can expect a questions purely on ER models. When it comes to the combinations of ER and relational models, you can expect questions on conversion on ER models to relational models. Conversion type of questions are possible. And next we will see with relational models. In relational model, we have discussed a data in the database is going to be represented in the form of a table. Each table is called a relation. Each table is called a relation. We have discussed some of the basic terminologies, because on terminology also in the previous gate questions were asked. Like I have discussed in the during the live sessions and physical classes that one theory questions. What is RET says? Like which of the following correctly describes RET? Right? What is RET? RET are also called cardinality of a relation, which is going to be represents the number of degree or RET. Degree specifies the number of attributes in a relation. There are certain options are given. So, means terminology is also important, because even 1 mark also very crucial for your admission into your IITs. Okay, what are the basic terminologies we have discussed? We have discussed about the basic terminology called relation, attributes, the basic terminology, and schema. What is a schema? Schema means structure. Instance. Instance means tuples present in a relation. and we have discussed degree. Question were asked on degree. What is the degree? Specifies the number of attributes of a relation schema. On the schema, how many attributes are there called degree? And we have discussed about cardinality. Because degree it is asked already, you may expect question on cardinality. What is a cardinality? Specifies the number of tuples in a relation instance. Means at that particular moment of time, how many tuples are there is called cardinality. Degree, cardinality. Then we have discussed about integrity constraints. So you may expect a questions on integrity constraints, and because questions were already asked also, but still there is a scope of asking questions on integrity constraints. What are the integrity constraints? We have discussed primary key. As you know, primary key will not allow duplicates, will not allow null values. Unique. What is unique? No duplicates, but nulls are allowed. Not null, duplicates are allowed, but null is not allowed, and combination of unique and not null is called primary key. And we have a check constraint for defining your own conditions. And next we have a foreign key constraints. We have foreign key constraint. What for foreign key? To show relationship between the two tables. To show relationship between the two tables, we use a foreign key constraint. Okay. So, primary key, unique, not null, check and foreign key constraints. And the questions were asked on foreign key constraints, and next we have discussed about key constraints. I am going to revise the concepts through questions, like as I have done for the previous questions. In the key constraints, this is important. We have discussed about candidate key. And moreover, if any specific thing is, do you have any doubt, you ask me to explain it in brief, I will explain you, do not worry. Candidate key, because some of the students I have observed, even now, some of the students are confusing with candidate key. And what is a candidate key? It is a set of attributes which uniquely identifies a tuple, and that set of attributes which uniquely identifies a tuple is called super key. And that super key, if it is minimal super key, then it is called candidate key, right? So, when I can call it is a super key, assuming when it is called, it is a minimal super key, assuming if A and B attributes together is a super key. When we can call that super key is minimal super key, so that it is going to become a candidate key. So, I can say AB is a minimal super key if A alone is not super key, A is not super key and B is not super key. If A is not super key and B is not super key, then AB is called minimal super key. That minimal super key is called candidate key. And it is important, more number of times questions were asked on that minimal super key, candidate key and all. So, first thing, it should be a super key. Second thing, the subset should not be a super key. If the subset is not super key, we can call it as a minimal super key, and minimal super key is called candidate key. And one of the candidate key should become a primary key, right? One of the candidate key should become a primary key. And we know the relationship. Every relation should have one primary key. That one we have to select from the candidate keys. And every candidate key is a subset of super keys. Every candidate key is a subset of super key. Fine. This is a relationship between the key constraints. And questions were asked like which of the following is a candidate key, not a candidate key, which of the following is super key but not candidate key, like that combinations of questions are asked and possible to be asked. And more importantly, the questions were asked on foreign key constraints. Even still, there is a lot of scope is there for asking questions on foreign key. And what are the points that we have discussed on foreign key? Foreign key can allow duplicates and null values. What foreign key shows? A relation between the two tables, and foreign key can refer to itself, means a same table can be act as a parent as well as a child. And we have discussed whatever the values present in foreign key in the child table, and definitely every value must be present in the parent table, but every value present in the parent table need not present in the child table. Means values present in foreign key definitely should be there in the primary key, but values present in primary key need not be present in foreign key, right? And violations. If you delete from the child table, means you delete anything from the foreign key, it does not causes any violation of foreign key constraint. But if you delete anything from the parent table, means in the primary key, and if you have a related tuples in the foreign key, then it causes a violation. It means inserting into the parent will not cause any violation, but inserting into the child will cause a violation. Means inserting into foreign key column may causes a violation. Deleting from the foreign key column will never cause a violation, but deleting from the parent table means primary key column will have a violations, right? And suppose if a tuple is to be deleted from the parent, the corresponding tuple is to be deleted in the child, then we use a condition on foreign key called on delete cascade. Along with cascade, we have set null and also we have a set default cases. What will happen? It will allow deletion from the parent, and if deletion happened on the parent, what action to be taken on the child? Cascade. Cascade means same action on the parent as well as child, or set null or set default. Okay, these are the possibilities on the foreign key, right? These are the possibilities on foreign key: on delete cascade, on delete set null, on delete set default. So questions were asked on these points. And still scope is there for asking questions on foreign key constraints. So when it comes to purely relational models, the scope of asking questions on terminology, and there is a scope of asking questions on foreign key constraint, and there is a scope of asking questions on key constraints, more specifically candidate key and super key. Now we'll see some of the questions so that you can review we will review the concept, and also you can parallel, you can check your knowledge. Okay. So look into that question. Fine. Suppose A1, A5 is the key. Combination of A1, A5 is said key, and generally key means it is called candidate key. Wherever they said just key, and keys means candidate key. For the relation R1 of A1 to A5, consider the statements given below. A5 may be a key. A5 is going to be a key? No, because a part of key never be a key, means part of candidate key never uniquely identifies. This is a false statement. And A1, A4, A5 is a super key. If it is to be a super key, what is required? It requires to have a candidate key, or we can call a super key is a superset of candidate key. Like A1, A5 already there, so its superset is always called super key. It is a true statement. A1, A4, A5 may be a key, but key in the sense candidate key. But if it is a candidate key, its subset should not be a key again. But A1, A5 already a key, it is called superset, but not because it is a superset. In that superset, its subset A1, A5 already is a key. So that it is a false statement, right? So what is the answer for this question? False, true, false. That is option D. Okay, A, B, C, D. Fine. That is an option D. Perfect. So majority people have selected the right answer. This is, you have to understand. Okay. And look at another question on foreign key. There is a question on foreign key. Consider the following relation R of x, y, z with x as the primary key and z as the foreign key, referencing x with on delete cascade. Suppose x2, y2, x1 if deleted, as a result, what will be the number of tuples in R after deletion? Okay, try. You can answer this question in the Q&A in the chat box, or else in the Q&A or chat box you can answer it, because it is a numerical type of question. Go ahead. So what was the question? Consider the following relation, right? R of x, y, z with x as the primary key. Okay, x is primary key and z as the foreign key. Z is foreign key referencing x with on delete cascade. This is a foreign key referring x with on delete cascade. Suppose tuple x2, y2, x1 if deleted, x2, y2, x1, x2, y2, x1, this tuple if delete. Suppose x2, y2, x1 if deleted, as a result, what will be the number of tuples in R after deletion? Okay, the question is what will be the number of tuples in R after deletion? Means after deletion, how many tuples are there in the R, right? Pradeep, sir, in mobile the screen is blur, but the laptop it is better. Just check it out, your internet connectivity. Look at, if this is deleted, what happens? Deleting from the foreign key will not cause any problem. Deleting from the primary key will cause a problem. Because on delete cascade means whenever you delete from the parent, means with respect to x I can call it as a parent, with respect to z I can call it as a child. Whenever a tuple is deleted from the parent, the corresponding tuple in the child also be deleted. It means x2 is in which tuples? In the z column. x2 is here, x2 is here also. In these two places x2 is there. So that this tuple is to be deleted, this tuple is also be deleted. And look at the deletion of the tuple, deletion of this tuple causing deletion of x3 here. Now we have to see any related tuples for this x3. That related tuple you have to check in the z column. In the z column, this is there. So it is also be deleted. Alright, and here also look at, this is also there, this is also to be deleted, right? Fine. Now when it comes to this tuple, here x4 is deleted. So whenever a tuple is deleted from the parent, related tuples from the child also be deleted, but x4 is not in the z column. So nothing, on deletion of x4, y2, x2, nothing is going to be deleted. And so what are the other tuples deleted? Now this is deleted. Now deletion causes x5 deleted, but x5 is not in the child, and deletion of this tuple causes x9 is deleted. But do you have x9? We don't have x9 in the column. So what are the tuples that are left after the deletion? After the deletion, which tuples are left? This is a one tuple, and this four all already deleted. This is another tuple. So means how many tuples are left after the deletion? Two tuples. So answer for the question is 2. Is it okay? Mallikarjun 2, and many people given 3, 4, 5 or something else. Now question is, as a result, what will be the number of tuples in R after deletion? After deletion, how many tuples are left? Only 2 tuples are left. Because only 2 tuples are left, answer will be 2. Is it okay? Because I am seeing different answers from different people. Here means maybe conceptual clarity is missing. Pradeep, got it? Navya, explain once again. Sir, but they said after deletion of x2, y2, x1, why did you delete remaining tuples? Haripriya, I hope you know the concept of on delete cascade. Whenever a tuple is deleted, x2, y2, x1, the related records we have to delete it. Okay, because it is a cascade option. If you delete that related tuples, and that tuples again may be related with some other tuples, and that tuples also to be deleted, correct? So means it is to be deleted cascadedly, means simultaneously you have to go on delete it. If you go on delete it, so these are the tuples that are deleted, and after deletion what is left is the answer. Is it okay, Haripriya? Rashi Mishra took as a number of tuples deleted. Rashi, so इसलिए मैंने बता रहे आपको क्वेश्चन को ध्यान से पढ़ना, राइट? क्वेश्चन को अगर ध्यान से नहीं पढ़ा, देखो कॉन्सेप्ट तो आपको आता है पर गलती करके बैठा है ना, कितना नुकसान हुआ आपका? अगर मान लीजिए ये 2 मार्क का क्वेश्चन है, 2 मार्क्स छूट गए और गलत की वजह से आपको नेगेटिव मार्क्स का भी पॉसिबिलिटी है, राइट? ओके, नव्या, यू गॉट इट? फाइन. Shirisha, sir, once can you explain again? Oh. Sarvesh, it is the same table will act as a parent as well as child now. So that's why. Look at. So where was a mistake you people have done? Now x2, okay, x2, y2, x1 deleted. Okay. Now I can call this is a parent tuple. For this parent tuple, what are the child tuples? Look, for this parent tuples, like x2 is deleted from the parent, Sarvesh and Shirisha, both of you. And maybe some of them are not asked, but still had a doubt. x2 is a parent, and the related tuples that you have to look in the z column. Why? Because with respect to x, I can call parent. With respect to z, I can call child. Whenever a tuple is deleted from the parent, you have to look the related tuples in the child. What are the child tuples? x3, y1, x2, x3, y1, x2, and one more is x4, y2, x2, x4, y4, x2. Now, because you are deleting this x2, y2, x1, because on delete cascade option is there, it is to delete these two tuples also. This is and these two tuples also. Now, when you delete these tuples, it is causing x3 deleted. It means again it is treated as a parent. Now, if it is deleted as a parent, now it is to be deleted its child. So, means this x3 is in how many tuples? In the z column. That x3 is in the z column in which tuples x5, y4, x3. Just I am writing x5, y4, x3 and x9, y5, x3. x9, y5, x3. So, because x3 is there in the child, whenever you delete from the parent, it is going to be child. Now, it means it is a parent. For this, these are the childs. When these are deleted, now for this, these are the parents for these two children. That is also to be deleted. When x4 is deleted, we have to look x4 in the child. Now, it is treated as a parent, its child. Like my father, for my father, I am a son. Okay. To me, my son is a like it is a hierarchy, right? So to my son, it is a grandfather and father and my son, right now. So hierarchy is to be maintained. Sarvesh. And for x4, we don't have x4 in the z column, means no child for this. And whenever you delete this x5, again you have to look its child. x5 is not in the z column and x9 is not in the z column, means these three do not have any children. For this, these two are children. For this, these two are children, and this does not have any children. That does not have any children. Okay. Fine, Sarvesh and Shirisha. Hope you understood. Okay. Thank you, Sarvesh. Shirisha, got it? Fine. Foreign key, you should not give up. Next, the questions are on translations. So, on relational models, purely you can see questions on purely on relational models, you can see questions on terminology, candidate key, super keys and foreign key constraints. And when it comes to the translation of ER model to relational models, what questions you can see? In translation of ER models to relational models, we know that every entity set is represented as one table, and entity set is to be represented as two tables. Tell me if there is a multi-valued attributes. These things we have discussed. And every relationship set, it is to be represented as one table, right? It is to be merged with entity set when we have to merge if there is a key constraint. Do remember these points. There is a key constraint. And we have discussed about cardinalities in many to many, 3 tables, in many to one, one to many and one to one. In all the 3 cases, there are 2 tables. And what is a one table case? The one table case is 1 to 1 with total participation. I am just have insisted many of the students to write short notes, but some of the students, most of the students are not taking care about it, but I hope you understand the importance of short notes. These points are all I have told you in the class. 1 to 1 with total participation. 1 to 1 with total participation will give you total participation from both sides. Will give you one table, right? And these are the important points. On this, questions were asked. I have discussed every point. And again, I am repeating, short notes is important. If you keep on repeat these things, you never forget it. Okay. Any special cases that we have discussed, hierarchical relationship, aggregation, on that no questions were asked, but scope is there for asking questions. Okay. Right. I hope you recollected these points, correct? Now look at this question, consider the below ER diagram and find the minimum number of tables required. Just go ahead with this question and try to answer in the Q&A. How do you answer? How do you answer? Just answer it. Answer it. Okay, fine. Satya, Lokesh, no wise. Aditya, I think 3. Manideep, check once again. Aditya, Shankar, 3. Yeah. How do you do this? One point I have explained during the live session also, E1 relation with E2. Say what we have discussed, if E1 is a key to E2, we have placed arrow here. So means one way of showing this notation is E1 to R, another notation is E1 to E2, both are same. Means it means E1 is participating with E2 through R with at most one relationship. So when in the case of at most one relationship, we can show E1 to R or E1 to E2, means either this arrow we put it or we put this arrow. But generally textbooks follows this arrow, but in one of the previous gate question, the arrow is given at this side, but both the meanings are same. Means E1 to E2 means without this arrow, here only we can have, or else we can have only here. But we know this notation, we are following this notation because we are following the standard textbook notations. So according to these notations, look at team to faculty, here arrow is there. According to our notation, I can put here, but generally we put entity to relationship. Faculty to team is an arrow. So faculty to HOD we put an arrow, and faculty to belongs to is an arrow, so that we put here. Just I am converting into the notation that we have discussed, so that there will be no confusion. And rating to faculty is an arrow, so arrow you can put rating to log. After that, once you place the arrows, you can go for mergings. And whenever there is a key constraint, means arrow is there to the relationship to be merged with entity set. So, okay, this is one merge, right? That is one. And here faculty with HOD and belongs to both are the arrows, so that we can merge faculty HOD belongs to. And here it is a unary relationship. It is a unary relationship, and team will have one table. And what about this relationship? This relationship cannot be merged with anyone else. So that how many tables it can have? It can have 4 tables. The number of tables are 4. Simple, keep the arrows and count it. Keep the arrows and count it. Okay. So anyhow, because arrow is there, log is to be merged with rating. And faculty to HOD arrow, faculty to belongs to arrow, these two you can merge with faculty. And even we do have team to HOD, so team and HOD you can merge it, and faculty and belongs to you can merge it, but that not gives any difference. And but ACE preparation league does not have any arrows with a team, so that ACE preparation league will not be combined with team, it should have a separate table. So how many tables are possible? 4 tables are possible. What you people given? And 3 is given majority. Manideep given 4. Very good, Manideep. Yes. It is not only Manideep, many people have given. Nibras Hassan 3. Nibras, check. Oh, many people given 3, 3, 3, 3, 3. Navya. So this is a Rashi, Harshada. No, I didn't expect it. Shubhangi, Akshay, Sridhar. Is it okay now after my explanation? Nibras, अगर एस प्रिपरेशन लीग को टीम से जोड़ना है, so आपको there should be a key constraint. If there is because key constraint is the only one which with that is a case, so that relationship you can merge with entity set. If there is no key constraint, you should not merge. Why? Because if there is no relationship, we call it as a many to many relationship. In many to many, we have to show relationship as separate table. Okay. How did arrow came from team to HOD? Actually, because we have a arrow from team to faculty, right? So that we can call, actually we are following this notation, entity to relationship. But what is given means, as I just want to say, right? Okay. So E1 arrow R with E2, this also can be represented as E1 R arrow is to E2, means you can keep arrow to E1 to E2 or E1 to R, both are same. So I have converted into comfortable way, because we have followed this one. Is it okay? Satya Lokesh, Nibras, ठीक है? Yeah. Fine. चलो. Done. So, try for this. Consider the following relation and find the minimum number of tables in relational model. So, questions are asked on minimum number of tables. So, the all chapters to be revised in the today's session only, but so please go a bit faster. Shravya, Sakshi Gupta, Rashi Mishra, good. Sakshi, Rashi, Shravya, Atharva Khale, Tejansh, Sriharshi, Gattu Tejaswini, Garv, okay, Kamini, check once again, Kamini, Anurag, Sriram, Akshay, Debmhal Bhattacharya, Sankhet, Venkat. It seems all of you are, it seems correct because majority is going this side. Pradeep, Nakka. Yeah. Consider the following relation and find the minimum number of tables in the relational models. How many tables in the relational model? Look at here, many means no arrows. One many means arrow is from many side. Do remember, today also we have revised this point. And because we have a three relationships, it is many, it is many, it is one many, and we know that many does not have any arrows. One many has an arrow from many side, okay, because it is an arrow from many side. Now what we have to do, you merge this R2, you merge this R2 with E3, merge R2 with E3. There is only one possibility. Any other mergings are possible? No. Okay, here maybe display issue, but you can observe it is a double ellipse. Double ellipse means multi-valued attributes. If you didn't observe because of display issue, no problem, but it is a E is double ellipse. E with has a double ellipse. Double ellipse is for multi-valued attributes. If it is a multi-valued attributes, it is to be represented with two tables. This is 1 and this is 2 comma 3, like two tables. And there are no mergings of relationships. So, relationships should be separately, and this is a fourth table and this is a fifth table and this is a sixth table. Suppose you haven't observed this multi-valued attributes, because I can say that that's a display issue. So, if you don't take this as a multi-valued attributes, it cannot be represented as two tables, then your answer should be 5 tables. But if anybody observed this as a multi-valued attributes, then your answer should be 6 tables. Okay. Don't worry. Those who have given about 5, happy. But if it is a multi-valued attributes you have observed, then it is 6. Because display issues are, we can't do anything. Fine. Okay, Rashi. But actually that is not displayed properly, so that I am not keen about that point. If it could have displayed clearly, it should be keen. Right? Anything? I hope you are clear with conversions. This is a slightly different question which I collected from different source. And, is the image is clear? If the image is clear, you can go ahead and answer the question. I will give a poll. If the image is clear, you can answer the question. I will give a poll. Consider the following entity relationship diagram. Which of the following options is R true? Okay, this is R true given. So, it is MSQ. Participation of product is total in prod del. Participation of product is total. Yes, double line says total participation. It is correct, true. The primary key in the relation schema for receipt, where is receipt? Okay, this one. This is a weak entity set. Why it is called weak? Because it is a double rectangle. Double rectangle is for weak entity set. The primary key in the relation schema for receipt is name comma item name comma production number. Because it is a weak entity set will have a key, partial key. What are the partial keys here in this case? Name and item name. And along with partial key, we can have key of the owner entity set. Now, receipt is for receipt, owner is product, and primary key of product is product number. Product number. This all three together is a key for this receipt table, and because it is a dotted underlined, we call it as a partial key. We call it as a partial key. So, what is given? Name, item name, product number. Okay, product number. Perfect. This is also true statement. And the primary key in the relation schema for the receipt will be, okay, receipt, primary key in the receipt will be name, item name and agent pin. It is false. Okay, just now we have discussed in the option B. So, A is right, B is right, C is false. Because B is right, C is definitely false. Participation of product is total in product record. Participation of product. Participation of product is total in product record. Okay, product in product record. Is it total participation? No, it is a single line. We call it is a partial participation. So, the last statement is also false. So, what is the correct answers? Both A and B. Okay, majority of the people have selected both A and B. Nice. Okay, these are the kind of questions can be asked on the conversions, and these are the expected types. Apart from that, you may not expect anything else. That is about ER models and relational models. Next, we quickly move to the next chapter called functional dependencies and normalization. Okay, in functional dependencies and normalization, what kind of questions you can expect? The type of questions are verifying, okay, verifying FDs, functional dependency verification. Okay, verify the given functional dependency. Means you will be given a table of data and asked to know which functional dependency is satisfied or not satisfied, and that kind of question. And second is about trivial FDs and non-trivial FDs. What is a trivial FD? When RHS is subset or equals to LHS of a dependency, then we can call it as a trivial FDs, and trivial FDs are always satisfied, right? Verifying FD, trivial FDs. And third type of questions. Third type of questions, what you can expect? Verifying FDs and trivial FDs and additional FDs. Means if you are given some dependencies and asked to find which of the following FD is satisfying on the relation. Suppose some dependency x to y, if it is to be verified, we can say x to y is possible if the closure of x contains y. That is a third type of questions, because on this type of concept questions were asked. And the fourth type, equivalences, equivalence of FDs. But equivalence of FDs so far not given, and I can say this is expected topic. And what kind of questions are possible to be asked, I have discussed during the live sessions and during the physical classes also. And fifth is on minimal set. And on minimal set of functional dependencies in 2017, only question asked, but after that and before that no question asked, but still scope is there for minimal set. Instead of asking in a regular way, maybe you may expect in a different way, minimal set of FTs. And sixth one, and finding the keys, and it is important, and different varieties of questions also we have discussed, and means regular type of questions were asked, but varieties of questions possible to be asked. Finding the keys, that varieties also we have discussed. And next, properties of decomposition, decomposition properties. It is also important, I can say, because questions were asked. Properties of decomposition. I am going to revise all these concepts with reference to questions. And we have two properties of decomposition, lossless join and dependency preservation, and how to verify lossless and dependency preservation properties, that we will discuss. Properties of decomposition, right? And these are the topics from where questions are possible to be asked, especially in the case of functional dependencies. And based on functional dependencies, we have a normalization, with normal forms are there. Okay, that we are going to discuss. Yeah, very first you can expect which of the following dependency verifications. You are given a table of data and dependencies are given, which dependencies are satisfying or not satisfying. That kind of questions are possible to be asked. Okay, check this question, check and answer this question. Which of the following functional dependencies hold on R? Is AB to C holds? For these two, AB is same, but C's are different, not holds. How to verify dependencies? If left hand side, if any two tuples are same, it is expecting right hand side also should be same. B to D, here left hand side B's are same, right hand side D's also same, it is very satisfying. D to A, left hand side DE, DE, these two are same, and right hand side A is also same, this is also satisfied. It means both 2 and 3 are satisfying, and the same thing you can expect as MSQs also. Means instead of giving like this, it will be given A, B, C, D. So, which dependencies are satisfying? Scope is there for asking MSQ type of questions. Okay, and this is one way of asking questions. And another is additional dependencies, like which of the following statements is are true? Okay, it is MSQ kind of question. It means you are given some dependencies and which dependencies are satisfied in the relations. Based on F, you have to find what other dependencies are there. This is based on the closures, and this is additional functional dependencies question. So, I think it is MSQ. I will give you a poll for this. Which of the following statements is are true? Just now we have discussed. The point is, if x2 y is a dependency, the closure of x should contain y. So, AC to F, how to verify? The closure of AC should get F. What is the closure of AC? AC, with A we have E, but we are not getting F, it is incorrect. How do you do this? ABC closure, left hand side closure we have to take to get the right hand side. ABC closure is ABC, with A we have E, with BC we have GD, and because D came, we will get F. So, E and F. So, it is correct. What is ABD to C? What is the closure of ABD? We will get ABD, with A we are getting E, with D we are getting F, but we do not get C. So, incorrect. So, answer is option B. And do remember, here in this only one option is correct, still it can be claimed as MSQ. MSQ means, many times I told you in my classes, MSQ means at least one option is correct. Even only one option is correct, it can be claimed as MSQ question. Okay? And do not think that it should be minimum 2, it should be at least 1. Minimum 1 is correct, not minimum 2. Okay, done. This is on equivalences, as I told you. On equivalences, questions were not asked, but I have collected this kind of question in some different sources to explain you what way a question can be expected. This is expected type of question. So this time I am definitely expecting a question to be asked on equivalences, because so far not asked. This time expecting to be asked. Answer this question. I'll give a poll. Consider the following relation: vehicle service, vehicle color, capacity, wheels, owner, with the following functional dependence sets. S1 we have 2 dependencies, S2 we have 2 dependencies. Which of the following statement is true? Neither S1 covers S2 nor S2 covers S1. Like, what is the meaning of S1 covers S2, S1 covers S2? It is meaning that dependencies of S2 you can get using S1. Dependencies of S2 are vehicle to color, capacity. If you have to check this, we have to take the closure of vehicle in the S1, means checking S2 with respect to S1. In the S2 we have vehicle to color, capacity. Now, is vehicle to color, capacity is there in S1? How do you do this? By taking the closure of vehicle. When you take the closure of vehicle in S1, vehicle closure is vehicle only. You don't have that dependency. It means vehicle to color capacity is not determined by S1. Means this first FD1 not determined by S1. FD1 of S2 not determined by S1. So means S1 is covering S2? No, this is incorrect. So S2 covers S1. How do you say? What is the meaning? Dependence of S1 can be determined by using S2. Now FD1 you look at. What is the FD1 of S1? Vehicle color is determining capacity. So what you have to do? Vehicle color closure you have to find in S2, because S1 dependency is verified in S2. What is a vehicle color closure? Vehicle color, with vehicle we have a color and capacity, and that's it, right? But what is to be verified? Vehicle color to capacity. Yes, it is getting. So this is possible. FD2 of S1. S1 we have to check with S2. What is FD2 of S1? Wheel closure. What is wheel closure in S2? Wheel closure is wheel, vehicle, owner, because vehicle is there, color and capacity is there. What is FD2 says? Wheels determines capacity and owner. Capacity and owner, both. Sorry, wheels will have vehicle, capacity and owner, all three. Means this is also possible. Means S2 is covering S1, but S1 is not covering S2. So it is given option A, neither S1 covers S2 nor S2 covers S1. This is wrong. S2 covers S1, correct. S2 is covering S1, correct. But S1 does not cover S2 is correct. S1 covers S2, wrong. Both are wrong. So correct answer is option B. I hope this concept is revised for you now. So how do you verify the equivalences? In this way you have to verify. Is it clear? Because some students answered wrongly also, but majority goes to the B option. Okay, that is perfect. This is about equivalences. Sandeep asking me to explain once again. Okay, what is the meaning of S1 covers S2? Sandeep, what is the meaning of S1 covers S2? Dependencies of S2 can be determined by S1. Whether a particular dependency of S2, is it possible to be determined by S1 or not? How do you do this? By checking the closure. Now FD1 of S2, FD1 of S2. Look at what is FD1 of S2? Vehicle to color capacity. This one you have to verify using S1. How do you do this? By taking the closure of vehicle. When you take the closure of vehicle in S1, you have to look at vehicle closure is vehicle, but what is expecting? Vehicle closure should have color and capacity. That is not possible with S1, so that S1 is not covering S2. But when you look for S2 covers S1, we are testing dependence of S1, FD1 of S1, FD2 of S1. I am checking with S2. How? By taking the closures. As we know that if the left hand side closure contains right hand side, we can say dependency possible, otherwise not possible. Okay, Sandeep Kumar, Garu Bansal. Okay, done. This is about equivalences and it is expected type. This time I am definitely say you can expect a question on this. Means my sense is saying. And next is on minimal covers. Next is on minimal covers. Let's solve this question on minimal covers. On minimal covers, so far only one question asked, but still there is a lot of scope of asking questions on minimal covers. Right? Try to solve. What is the meaning of minimal? You know it. What happened to you? Less people are answering. Have you practiced minimal cover? Consider relation R of A, B, C, D, E, F, G and the FD set F1, this is the dependencies are given. Let F dash be a minimal cover of F1. Let F dash be a minimal cover of F1. Find out the incorrect statement about F dash. Okay, F dash is minimal cover. So here you need not to find what is a minimal cover for it. Simply what you have to look is F dash contains F2D. When F2D is going to be there in the F dash, if F2D can be determined using the remaining set of dependencies. What is F closure in the remaining set of dependencies? Because to verify F2D is possible to be determined using the remaining set of dependencies, you just check with what is F dash closure. What is F dash closure? F dash closure is F with the remaining set of dependencies. Because F dash closure is F in the remaining set of dependencies, but not D, it means F2D cannot be determined using the remaining set of dependencies. Because F2D cannot be determined using the remaining set of dependencies, F dash can contain F2D dependency. This is correct. F dash does not contains DE to F. Does not contains means DE to F is going to be deleted. Here DE to F. When I can say DE to F gets deleted, when you take the closure of DE with respect to other dependencies, means when particular dependencies should be there or not, we have to check by using other dependencies. When you take the DE closure with respect to other dependencies, DE closure is DE, with E we have F, G, B, right, and with EG we have CD, and with B, C, G we have CE, that is already there, and with F we have D, that is also there, with B we have ACD, because in the first dependency we have. But what is expecting with DE, we should get F. With DE we should get F. Are you getting DE to F? Yes. We are getting DE to F, it is a meaning that we are getting DE to F. It is a meaning that DE to F can be deleted. Yes, this is also correct statement. But question is about incorrect statements. So B is also correct because DE to F you can get with other dependencies. So that DE to F can be deleted. and f dash does not contains EG to CD, where this one. Whether EG to CD, if it is not containing, then means EG to CD is eliminated. EG to CD can be eliminated if it can be determined with other dependencies. What is EG closure? EG. Other dependencies, with respect to other dependencies, you check it. EG closure is EG. With E, we have FGB. With F, we have D. With D, we have F. With B, we have ACD. Look at, with B, first dependency, ACD. What is to verify with EG? With EG, we have to verify C and D. Means EG to CD, you can get with other dependencies, because EG to CD we can get with other dependencies. EG to CD also can be eliminated. Means this is also correct statement. Right? 8 minutes are over. Only 11 students are answered correctly. That is also correct. Fine. Next, f dash does not contains BG to E. Is BG to E is possible? F dash does not contains BG to E, because A, B, C are correct options. So question is about to select incorrect options. So I can say D is the incorrect options. F dash does not contains BG to E. BG to E, actually here BCG is there, where if C gets deleted, you can have BG to E. Look at, because B is determining C, and both B and C they are in the right hand side, left hand side. So C can be deleted. So it causes BG to CE. It means that BG to C possible, BG to E possible. It means BG to E you can see in the minimal set, but it is said does not contain. So it is incorrect statement. Question is to select incorrect statement, that is an option D. Okay. Is it clear? Fine. Just look into that solution. If you have any doubt, you can ask me. Just give a minute. Okay, Nakka Nitin asking me to solve the, but actually if you have to solve it, it is waste of time, because so many dependencies are there. Just go with verifying the dependencies, but still Nakka is asking me to explain the minimal cover. So let me write the dependencies: B to ACD and D to F, F to D, E to FGB and BCG to CA, BCG to CA. Fine. And EG to CD. EG to CD. What you have to do first, remove from the left hand side. Can D, anything to be eliminated? Do we get D from E? E to F, F to D. E to F, F to D. E closure contains D, this D can be eliminated. Can you get E from D? No. Look at, with E we are getting F. How? E deriving F, F deriving D, so that with E we are getting D, D eliminated. And also you look at, with the B we are getting C, so C eliminated. With B we are getting C. Look at, with B we are getting B to C, B to ACD means B to C there, C can be eliminated. And anyhow, see whatever BCG to G there, so BCG to C, when RHS is subset of LHS, that is trivial, that is also eliminated. And G to B not there, E to G, look at, because E is deriving G, look at E deriving G, E to FG B there na, E deriving G, so that G can be deleted. So after this option, what is left? B2 means after this step, we have left with B to ACD. In D to F, D deleted. What is left is E to F, F to D, and BG to E, right? C eliminated because B to C there, and C in the right hand side is eliminated because it is becoming trivials. Trivials are always possible. And E to CD. E to CD. Fine. And what is next? Look in the right hand side. Look in the right hand side. Before that, you just check for B to G. B to G, B closure, is it deriving G? B to A, C, D. I think you're not getting. Okay, fine. Now, look at B to ACD. B to A possible with other dependencies? No possible. B to C possible. How do you check? B closure to find C with other dependencies. That is not possible. B closure with other dependencies to find D, but not possible. So, B to ACD is required in the final answer. E to F, E closure you have to find to get F using other dependencies, but E closure in the remaining 4, like I am calling 1, 2, 3, 4 and 5. E to F we have to check, means E closure you find with 1, 3, 4, 5. E closure with 1, 3, 4, 5 is E only, not F. So, E to F is also required. E to F is also not. E to F does not contains D to F. Check it, this one. Right. Next, F2D, F closure with other dependencies. F closure with other dependencies, you are not getting. So, F2D. BG closure with other dependency, BG closure is BG closure with respect to 1, 2, 3 and 5. BG closure is BG, ACD you are getting, but not E. So, BG to E. E to CD with respect to other dependency, E closure is EF with FD, and you are not getting CD from other dependencies, so that E to CD is possible. Anything more? No more. This is the minimal cover for the given question, but instead of doing all this, you can check with those ways. In this directly the options you have to check. A particular dependency is to be eliminated if that closure, left hand side closure contains right hand side, then that is going to be eliminated. Fine. Is it clear? Any doubt? E to FG missed. Oh, I missed this dependency. Fine, fine. That's what I am looking into it. E to FG missed. Fine, fine. I haven't written E to FG dependency. Fine. So, the answer could be changed because I missed writing that E to FGB. Okay, when I write E to FGB, your answer could be something different. B to ACD I have written, E to F written, F to D written, BG to E written, E to CD. Okay, this E to FGB this one, E2FGB. Now your answer is going to be changed totally because that is missed. So some bit be careful. B2ACD. Now with B, or else first you look at, I gave you one trick, how many times a particular attribute appeared in the right hand side. If a particular attribute in the right hand side appeared for only one time, that is essential dependency. A appeared only one time, B2A is required. C there for 2 times. So C there for 2 times means B2C possible with respect to other dependencies. B2C possible with respect to other dependencies. How do you do this? B closure you have to find with respect to 2, 3, 4, 5, 6. What is B closure? B, A, D, but you don't get C, C is required. And B to D, D is there for 2 times. You have to check, is it possible to be derived from other dependencies? Means B closure you have to find with respect to 2, 3, 4, 5 along with B to AC. What is B closure? B, A, C, but not D. So B to A, C, D is required. E to F. E to F is going to be eliminated if E closure contains F with respect to 1, 3, 4, 5, 6. E closure is E, C, F. F you are getting now, that is deleted. F to D, F closure. D is there for 2 times. F closure with respect to 1, 4, 5, 6. F closure is F only, so that F to D cannot be deleted. And BG to E, BG to E, is it, if it is to be deleted, E is there in the right hand side only for one time. So if it is one time, it is compulsory. It means that this E can be derived using only BG but not with any other dependency. That is also required, right? And E to CD, if it is to be deleted, you have to check. E closure should contain C and D from 1, because 2 already deleted, 1, 3, 4, 6. What is E closure? E, F, G, B, with B we have a C. So C deleted, and D also, D deleted. It means that this entire dependency deleted. And E to F, F already once deleted, now only one time. G only one time, B only one time, means E to F, G, B. Okay, because I haven't written this dependency. So see, a small ignorance will pay you a lot, right? You have to pay a lot. So now the answer is this one. This is a minimal set. This is a minimal set. Now what is the option A given? F dash contains F to D. Yes, F to D there. Option A is correct. F dash does not contains DE to F. Is DE to F is there? No. So it is also correct. F dash does not contains EG to CD. Is EG to CD is there? No. F dash does not contains BG to E, but BG to E is there. So but it is given does not contains, it is an incorrect statement. Okay, fine. Because of lights, actually the problem is because of lights. So I didn't check this one. If because I didn't wrote this one, now because I have written, now I got the final answer, that is a minimal set. So this is about minimal sets of dependencies. This is about functional dependencies. And next we'll take a break. After the break we'll continue with how to find the keys and all. Keys, normal forms, then we'll follow with algebra, calculus, then SQL, then transactions and concurrency, recovery, and then followed by indexing, then data warehousing. Okay. So we have seen so far till functional dependencies. Next we'll go ahead with finding the keys. Next we'll go ahead with finding the keys. Now how to find the keys? As we know it, if we have to find a key, the closure of that key should contain all the attributes. Suppose assuming some attributes, like some attributes that I am calling X, if X is going to be a key, the closure of X should contains all attributes. If the closure of X contains all attributes, then we say X is super key. If X is minimal super key, then X is candidate key and one of the candidate key will be used as a primary key. That we know it. And again, I want to repeat it. What is the minimal super key? Assuming the A, B attributes together, we call it as a super key. If A alone is not super key and B alone is not super key, then AB is called minimal super key and a minimal super key is called candidate key, right? This point keep in mind, again and again I am repeating, this point you keep in mind, most of the students are confusing in this point. You should not confuse so that you will give the correct answer. Done? Now, look at based on that multiple times, multiple questions were asked and this is one of such kind. Suppose a relation R of ABCD has the following dependencies, which of the following is not a candidate key? Which of the following is not a candidate key? So, which is not a candidate key is the question, right? Okay, try. Sir, I have a doubt in super keys related questions, as many formulas are there to find super keys. Not many formulas, okay. You are feeling it as a many formulas, it is a meaning that you are missing conceptual clarity. So, okay, fine. Just let me know your doubt so that I can give a clarity on this. Sakshi? Right? Okay, it is 1 minute. Almost many students have answered the question. Okay, still. Suppose a relation R of ABCD with functional dependency is given. Question is which of the following is not a candidate key? Actually, this kind of question not asked, but question is not a candidate key. So far, the questions that were asked is which of the following is candidate key, super key, that kind of questions were asked. But okay, not a candidate key. How do you check whether it is a candidate key or not? By finding the closure. First thing, options I am checking. A closure, A, B, with B we have C, with BC we have A already there, with A we have D, with D we have E, all attributes, it is super key, and super key with one attribute is always candidate key. But question is about not a candidate key, option is wrong, it is a candidate key. And because A is a candidate key, look at A is a candidate key, is A in the right hand side? Yes. A in the right hand side, because E to A there, when A is in the right hand side, it means A you can also get with E, it means E is also candidate key. So that B is wrong. When E in the right hand side of D to E, when E is a candidate key, then D is also candidate key. But anyhow D, okay, D is a candidate key, it is also not correct, right? And A to D there, D can be replaced with A, or A already candidate key. Now, A in the right hand side of BC to A, so A is a candidate key means A replaced with BC, BC is a key, but when here we have to look for it. When BC is a key and A can be replaced with BC, but you look at, we have a B to C dependency. It means C can be replaced with BC, C can be replaced with B here. If C replaced with B, now this is going to become B. It means B is also candidate key. What are the candidate keys here? A, B, D, E, all are candidate keys. When A, B, D, E is a candidate key, if B is a candidate key, then BC is called super key, not candidate key. The question is about candidate key, not super key. BC's closure contains all attributes, okay. When BC closure contains all attributes, we call it as a super key, but B is already candidate key. Because B is candidate key, BC is called super key, but not candidate key. Answer is option C. Okay, fine. Okay, look at this question. Maybe Sakshi, you are having a doubt of solving this kind of question. Sakshi, have you posted your doubt? If number of super keys are these many given, you have to look for the possible cases. Means if A1 candidate key, how many super keys are possible? Like we have to check possibilities and remove those them. M is less than or equal to. Okay, M simple candidate keys means M attributes are candidate keys. Very good. How many super keys are possible? I suggest you, Sakshi, instead of me to answer the question, what I suggest you is, you just take simple example of 4 attributes, 3 attributes, okay, and or 5 attributes, 4, 5. In that, in one case you take only 2 attributes as a candidate case. In another case, you take only 3 attributes as candidate case, 2 attributes as candidate case, and check with the possibilities. You will get some relationship. If you find it, you will get a more clarity. Okay, is it clear? Just try and let me know. If not, definitely I am there for you. Means you will get a generalized formula because all are simple candidate case now. Just try with some example. So it is a case is different, na Sakshi. The case is different here. Why? Because all are simple candidate case. If combinations of attributes is candidate case, then that is going to be different. Tejanshu, here you are saying that A, B, C, D, E, A, B, B, C, C, D as candidate case. Then if 3 candidate case, you have to go with the set method. Okay. Right. Oh, sorry, here I have started a poll, but which is a numerical answer type question. Sorry. The answer for this question is it 6? Okay. Somebody is asking, sir, any common attributes? Okay. Look, a relation R has 2 candidate keys with 1 and 2 attributes. With 1 and 2 attributes. Now tell me, can you expect any common attributes, Vijay Kumar? If it is a common attribute, if one candidate key is 1 attribute, another candidate key is 2 attributes. Suppose that one attribute of a candidate key is common with 2 attribute candidate key. If it is common, then it is not a candidate key, right? That point you should focus on it. This is a key with 1 attribute, this is a key with 2 attributes. If the same attribute is common, then 2 attributes is not considered as a candidate key, that is a super key only. So means these two are definitely different. Okay. So assuming this is A, this is BC. There are 40 super keys, totally 40 super keys of R. What is the total number of attributes in R? Now assuming total attributes are n. So we have to find n value. Because 2 candidate keys, one candidate key with 1 attribute, another candidate key with 2 attributes, then how do you find the super keys? To the power of number of non-prime attributes. So one attribute is candidate key, remaining attributes, with remaining attributes it will form a super keys. So how many super keys possible with one attribute candidate key, 2 power remaining attributes. So what are the remaining attributes? N minus 4 plus with 2 attributes candidate key, how many possibilities? 2 power n minus 2 possibilities minus anything common here, no common. If it is no common, 2 to the power of n minus of one candidate key plus one candidate key with one attribute, another candidate key with two attributes. So means n minus key attributes. Key attributes are going to be common in both of them. Okay, this is equals to how much? 40. Now you can go with the trial and error method, simple. If n is 5, suppose for n equal to 5, just randomly I am checking because 40 na, n equal to 5. 2 to the power of 5 minus 1, 4, 16 plus 2 to the power of 5 minus 2 means 2 to the power of 3, 8 minus 2 to the power of 5 minus 3, 5 minus 3, 2 means 4 equal to 40, true or false? 16 plus 8, 24, sorry, it is 2 to the power of 2, 2 to the power of 2, 2 to the power of 2 is 4, right? This is 4. It means equal to 40, wrong. So for n equal to 6, you can try. 2 to the power of 6 minus 1. 2 to the power of 6 minus 1 means 5. 2 to the power of 5 is 32 plus 2 to the power of 6 minus 2 means 2 to the power of 4, that is 16. 32 plus 16, 48 minus 2 to the power of 6 minus 3 means 2 to the power of 3, 8. 32 plus 16, 48 minus 8, 40. This is correct. So the number of attributes are 6. That's it. Is it okay? You have to solve this way. We have discussed this kind of things during our lectures, right? Okay. Then the number of prime attributes in R is, okay, this is another type of question about prime attributes. It is also expected type of question because you can expect questions on prime attributes. How many prime attributes? How to find prime attribute? What is a prime attribute? Attributes of a candidate key called prime attributes. Now you have to find what are the candidate keys to know what are the prime attributes. Okay. So what is the candidate keys? By looking we can say AB closure is ABC, all attributes. Because C to B there, you replace B with C, AC. Now how many candidate keys for this? 2 candidate keys. What are the prime attributes? Attributes of a candidate key, A, B, C. Any non-prime attributes? No. The question is about number of prime attributes, 3. Simple. Instead of asking you number of prime attributes, they may be ask you number of non-prime attributes. Then we can say 0. Next, those are the kind of questions on keys. Okay. Next, we have to go with the properties of decomposition. What are the properties of decomposition? There are 2 properties of decomposition. One we call lossless joint decomposition. Lossless joint decomposition. When we can call decomposition is lossless? When we can call decomposition is lossless? We can say the decomposition is lossless if R is decomposed into R1 and R2. When you join these 2 relations, you should get R back. Then we can call the decomposition is lossless. And what is the keynote point for the lossless decomposition? The keynote point for the lossless decomposition is the attribute common to R1 and R2. So means intersection we will be finding. That attribute common to R1 and R2 should determine the attributes of R1, R should determine the attributes of R2. It means the common attribute should be a key in either R1 or in R2. If it is a common attribute is a key in either R1 or R2, then we can say the one of the table will be acting as a parent, another table will be acting as a child. When there is a parent-child relation between the 2 tables, we can say if there is a parent-child relation between the 2 tables, we can say the decomposition is lossless. Otherwise, the decomposition is lossy. If you have multiple tables, you can try in this way. Just check for the possible combinations. This is for the lossless joint decomposition. And another property is dependency preserving decomposition. Dependency preserving decomposition. So, means decomposition should preserve the dependencies. Suppose R has some dependencies F, and if it is decomposed into R1 and R2, and R1 had some dependencies F1 and R2 had some dependencies F2, and definitely these F1 and F2 will get dependencies that are subset are equals to F closure. We can say the dependency preserving decomposition, if every dependency of F, we can say it by using F closure, we can get using the dependencies of decomposed relations. What are the dependencies of decomposed relations F1 and F2? Their closure should definitely be same. Then we can say the decomposition is dependency preserving decomposition, otherwise dependencies are lost. So, what we have to do? So, on a given relation, what dependencies are satisfying on each relation we have to find from the F closure. By taking the closure, we can get to know it. Once we find all the dependencies in R1 and R2 from F closure, we have to check the dependencies of R. Is it possible to be get using F1 union F2? We have to check. These are the two properties of decomposition, and solely on dependency preservation, questions are not asked, only on dependency preservation, so that it is expected. So, scope is there for asking. This time, scope is there for asking questions on dependency preservation, purely on dependency preservation. But I think we can see, I think, one question on combinations of lossless and dependency preservation, but only lossless questions were asked. This is important anyhow because it is asked for multiple times. But this time only on dependency preservation you can expect it, because I sense it, this time question paper is going to be tough. So, tough in the sense not the regular kind of questions, concept, no one changes the concept is always same, concept is same, but the way of asking questions might be different, and there may be possibility of more untapped area questions. So, possible this time. So, I am not scaring you like okay, आपको मैंने नहीं डरा रही, but just I am going to tell you the fact which I sensed it. I sensed it, okay, this time paper could be tough and tricky and different type of questions आपको देखने को मिलेगा, पक्का, मैंने sense कर रहे. Okay, this is about two properties of lossless joint and dependency preserving decomposition. Now, we will see some questions, so that you will also, I will explain you the concept more clearly with respect to questions. Before me, I just suggest you to try. Go ahead. Yeah, actually it is a simple question. What is given? R1 ABCD and R2 is DE. Very first we have to check for the lossless joint decomposition. So, what is a common? D. What is the closure of D? DE. It means it is deriving the attributes of R2. So, means in R2 D is a key, in R1 D is a foreign key, it is a primary key. Now, parent-child relationship is there, then decomposition is lossless. So, option A is correct. And whether it is dependency preservation or not, how do you check? Check what dependencies are satisfying on R1 and what dependencies are satisfying in R2. Just write A to BC in R1, C to DE. In C to DE, we have a C to D and C to E. Okay, C to D you can write in R1 because both C and D are there in R1. And C to E you cannot write in R1 or R2 because both are not there in either R1 or R2. D to E you can write in R2, right? Now, much complication I do not want to do it, because by finding all the dependencies, by looking we can understand what is not covered directly C to E, but look at, by looking F1 and F2 I can say C to E there, C to D, D to E, C to E is there, right now. So, because whenever it is directly I can sense it and I can see it, no need to write all the dependencies which are covered by R1, which are covered by R2, and then checking for C2E dependency, because C2E is not covered, that C2E is covered from F1 union F2, then I can call dependencies are preserved. So, it is lossless and dependency preservation, lossless and dependency preservation, both A and C. Okay, right. That is a simple question. Now, slightly different one on lossless decomposition. Check for this lossless and dependency preservation. The next question. Again, I am launching the poll. Check it, solve it with a little patience. Take maximum of 2 minutes for this question. And moreover, if you I think you are habituated of solving the questions with relation with attributes like A, B, C, D, E given, then it could be easy for you. But whenever you are given this kind of questions, you just code it, or else do not worry, instead of A, B, C, D, E, they have given pole type, cause, severity, effect and all. If you are not comfortable, just code it and solve. Code it in the sense, you can use some simple letters. Yeah, fine. Okay, just I want to close this poll, but already 3 minutes is over for this question. Nibra, C, Tejanshu, Sakshi, Muhammad Abdul Zunaid, अब तो डी दे दिया अब्दुल जुनाइद, बाकी लोग ने सी दे रहा है, जस्ट चेक ना. चरिता, श्राव्या, ओके, गुड 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 गुड. Fine, I ended the poll because 3 minutes is the maximum time for any question you can get. So, nearly 55 students have answered, but 31 students answered C. Look at, there are 4 dependencies are given and the relation decomposed into 2 relations and the population 1. Okay, I have to change the color. Yeah, here one table is called population 1, have a population type, cause. Okay, 1 minute. I will just coding it, so for my easy understanding. Population type, cause, severity, effect. There is a population 1 table and another population 2 table is having population type, severity, measure and target zone. Target zone I am calling Z. Okay, target zone Z. First thing we will check for lossy or lossless. To check for lossy or lossless, there should be some attribute common. What is a common attribute? The common attributes for this is a T and S is a common attribute. Means population pole type and severity are the common attributes. So, when you take the closure of this pole type and severity, pole type and severity, and pole type is determining the cause and severity is determining the effect, right? And pole type and measure not there, and cause and effect is deriving measure and the severity already there. Now pole type, cause, severity, effect, measure, zone. But when it find the TS closure, it is finding TSCE. This is P1 attributes are determining. Because P1 attributes are determining, TS is called a key for P1 relationship, like pollution control 1 relationship. And because it is a key in pollution control relationship, the decomposition is lossless. Okay, first thing is clear, it is lossless. Because option B is said neither lossless and option D said lossy. These two are wrong, B and D are wrong, but few people have selected B and D also. But this decomposition is lossless. And for dependency preservation, just I am looking TCSE are the attributes, and pollution control 2 will have TSMZ are the attributes. Fine. Now, what dependencies are there? Pole type to cause, pole type to cause, I can write in pollution control 1 table, and severity to effect also I can write in pollution control 1 table, and pollution type measure is determining the target zone, PT determining Z, but PT determining Z, T pollution type T and measure. So, lighting effect is dangerous. Sorry, actually here it is affecting pollution type and measure. Type T, measure M is determining the zone Tm to Z. I can write here Tm to Z, and cause effect to measure severity. Cause effect determining measure and severity. CE to MS. Okay, CE to MS. CE here, MS there. So, this is going to be verified indirectly. Because that is to be verified indirectly, you just need to know what are the other dependencies possible in P1 table, P2 table. In P1 table, we have a dependency with respect to T and S. We don't have a dependency with respect to C and E. We just check with any dependency possible with C. What is C? C is called cause. When you take the closure of cause here, cause closure is cause, you don't get anything. And check any dependency possible with E, effect closure. Effect closure is effect, you don't get any dependency on P1. And in P2, we have a dependency with respect to T and M. Try with S and Z. With S, severity, if you take the closure of severity, you are going to get severity, effect, but which is of no use. When you take the zone, zone closure is zone only, you don't get any other dependencies. It means you are not getting any dependency with respect to C, E, with which we have no dependencies in P1 table. With T and M we have dependencies, but with S and Z we don't have any dependencies. We verify any dependency possible with F, severity, by taking the closure of severity. When you take the closure of severity, you are going to get severity, effect, but effect is not in the table, but you are not getting any other attributes. Similarly, we can check for target zone. When you take the target zone closure, you will get target zone only, means no more dependency. But what we have to verify, CE to MS, that CE to MS you have to verify using the F1 dependencies and F2 dependencies. What is CE closure in F1 and F2? CE, that's it, but you don't get MS. Because you don't get a MS, we can say the dependencies, this dependency is going to be lost. We can say not dependency preserving, we can say it is not DP. So, means the decomposition is lossless but not preserving the dependencies. lossless is correct, not dependency preserving is correct, then is option C. So, A is wrong, option C is right. CE to S be in pole type, pollution type 1, CE to S. Where is CE to S? Okay, CE to M not there, na? Okay, CE to S. Okay, here CES is there in this. Okay, fine. I can take CE closure, but CE to M is missing, right? What I can say? CE to M is not preserving. Okay, fine. But anyhow, answer is same. CE to M, that is not an effect here. Okay, Vijay Kumar Reddy. Okay, Sangamitra, right. Okay. Vijay Kumar Reddy, sir, you said something about spurious tuples during online class. Can you revise that once? Okay, Vijay Kumar Reddy is asking about spurious tuples. So, what does it mean, spurious tuples? Spurious tuples is nothing but extra tuples or incorrect tuples. That should not, uh, even if a spurious tuples occurs, we can say the decomposition is lossy. What actually meaning that spurious tuples? Like Vijay Kumar Reddy is asking about spurious tuples. Suppose R is AB and R2 is BC, assuming what is a common attribute? Common attribute is B. So, B should be a key attribute in either R1 table or R2 table. Suppose if B is not key in R1 or R2. So, assuming RABC is having 2, 1, 3, 3, 1, 2, assuming this table 2, 1, 3, 3, 1, 2. Now, how it is decomposed? It is decomposed into AB like 2, 1, 3, 1, BC 1, 3, 1, 2. Now, when you perform a join between them, actually when I can call decomposition is lossless, if you join these two decomposed relations, you should get R back. When you join these two tables, how do you join with respect to common attribute? What is a common attribute? B equal to B. When it is B equal to B, now you are going to get R ABC, you have to get, okay, R dash ABC. Now 2, 1 matching with 1, 3, so 2, 1, 3 possible. 2, 1 matching with 1, 2 also means 2, 1, 2 is also possible. 3, 1 match with 1, 3, 3, 1, 3 is also possible. 3, 1 match with 1, 2, so 3, 1, 2 also possible. Now this is R dash relation, but what R has? 2, 1, 3, 3, 1, 2, but what about these two tuples? These two tuples are not there in R, but is there in R dash, and these are called extra tuples. These extra tuples are called spurious tuples. These extra tuples are called spurious tuples, and because spurious tuples are occurred, the decomposition is lossy. Actually, what I told you now, generally the people had a perception if the decomposition is lossy means they feel that it should lose some tuples. Lossy does not mean it loses the tuples. Lossy mean that it will generate some extra tuples called spurious tuples, which are called incorrect tuples in the database. And generating incorrect data is also considered as a lossy. See, because it is a lossy decomposition, now we can say R dash is superset of R. If it is lossless, R and R dash are same. If it is lossy, R dash is superset of R. Why it is superset? Because R dash has spurious tuples. Is it okay, Vijay Kumar Reddy? And anyone else also having a doubt with spurious tuples? I think it got clarified. Okay, Vijay Kumar Reddy? Right? Shirish, I have written that. Done. That's about properties of decomposition. Questions were asked on properties of decomposition, focus on them. So, more scope is there for asking more questions. Normal forms. Next, we will go ahead with the normal forms. We started with unnormalized relation. When I can call a relation is unnormalized, we can say a relation is unnormalized. It is not a normalized relation. If it has multi-valued or composite attributes. If we remove multi-valued attributes and composite attributes, we can say the relation is we can say relation is normalized and we can call 1NF. What 1NF allows? Only atomic values. Only atomic values are there in 1NF. And if you remove the problem of partial dependencies, partial functional dependencies. And do remember what is the format of partial functional dependency? Left hand side should have part of key, right hand side should have non-key. Then it is called partial dependencies. If you remove the problem of partial dependencies, we can say relation is in 2NF. And what 2NF allows? Only full functional dependency, means no partial dependencies, full dependencies are allowed. But 2NF suffers with a problem of transitive dependencies. It requires to remove the problem of transitive dependency. Recollect what is the format of transitive dependency? Left hand side non-key, right hand side non-key. It is called transitive dependency. If left non-key, right non-key, it is called transitive dependency. If transitive dependency is there, we have to remove to make the relation into 3NF. 3NF had a rule that if x2 y is a dependency, if x2 y is a dependency, x is going to become super key or y should become prime attribute. As you know, what is the meaning of prime attribute? Prime attribute is attribute of a candidate key, right? Either or condition. But 3NF suffers with a problem of prime transitivity. So, if we remove the problem of prime transitivity. Now, what is the meaning of prime transitivity? Left hand side prime attribute, right hand side prime attribute, we call prime transitivity. Then we can say relation is in BCNF. Now, when I can say BCNF, if a dependency x2y is there, x should definitely be super key, nothing else. Then we can call relation is in BCNF. So, what is the format of PFD? Part of key to non-key. What is the format of TD? Non-key to non-key. What is the format of prime transitivity? Prime attribute to prime attribute. And here for you I will write partial dependencies had a point part of key to non-key. Transitive dependencies means a non-key is determining non-key. And a prime transitivity means prime attribute determining prime attributes. And these cases we have to look. And what normal form says? The highest normal form condition. The highest normal form condition we can say BCNF. If not, then we have to say 3NF. If not, we have to say 2NF. If not, we have to say 1NF. If not, we can say unnormalized relation. And as I told you, this slide in the live classes and the physical class also I told you, this summary and this slide is helpful to get 2 marks easily in your exam. Just you can go through this, you will easily understand this, you can easily solve the questions, okay. Try this question, just try it. Consider the relation guest, phone, name, address, room, floor, stay, and which satisfies the following functional dependencies FD1, 2, 3. The given relation guarantees which highest normal form. To find normal form, first you have to find a keys. Now, what is the key for this? Because address, room, floor stay in the right hand side of the dependencies. You can take the closure of phone and name. When you take the closure of phone and name, phone, name, address, with name we have floor, stay, and with phone we have a room. All attributes you are getting. Now, the key is phone and name, that is a key. Because phone and name is a key, the remaining attributes are non-keys. It means here phone is part of key, and room is non-key. Part of key to non-key is called partial functional dependency. If partial dependencies are there, relation is in which normal form? First normal form. That's it. If partial dependencies, relation is in the first normal form. Right? Okay, that's simple. Look for this question. It is slightly different than what was asked in the previous gate. So, I tried my best to collect some new type of questions. It is slightly different. Look at consider relation schema, online class, class ID, class link, subject, mentor. Which of the following set of functional dependence should be chosen so that online class can be in 2NF but not in 3NF? Okay, just slightly different kind of question. Take 2 minutes for this question and answer it. Consider relation schema. It is given class ID I, class link L, subject S, mentor M, duration D. And we have okay, options are given, the dependencies. The question is which of the following set of functional dependencies should be chosen such that online class be in 2NF but not in 3NF. When I can say a relation is in 2NF, no partial dependencies. When it is not in 3NF but transitive dependencies. So, means no partial dependencies but transitive dependencies. No partial dependencies means no part of key to non-key, but transitive dependency expecting means non-key to non-key should be there. Okay, right. In the case of first one, what is a key? It seems class ID is a key. Okay, because when I take the closure of ID closure, I closure will take I, L, S, with L we have a D, ILSD. ILSD, M is not covered, M is not covered. LSD, LSD is there, I is not a key. So, M is, what is M? M is independent attribute. When you take the closure of M, M closure is M, S, not getting all attributes. So, to M if I add I am going to get all the attributes. IM closure is IM with ILSD is there already. So, what is the key for the first question? The key for the first question is I and M. If I and M is a key, M is part of key, S is non-key. So, part of key to non-key. Majority people have selected option A. Anything wrong? Anything wrong from my side? Because when majority is selecting option A, I am just thinking about it. Now, what is the key here? I and M only, na? Means class ID and mentor together is a key. When class ID and mentor together is a key, mentor is part of key, subject is non-key. It is called partial functional dependency. If it is partial dependency, it is 1NF but not in 2NF. But question is, it requires to be in 2NF. Option A is wrong. So, majority is going wrong. Almost 46% of the students selected option A. Please check where you have done a mistake. And please try not to do the same mistake. Next, when you look for the option B, what is a key? ID, okay, I will write with some different color. Is it visible, blue color, or else I will go with some different color. So, option A is wrong, look for option B, class class ID comma link. When I take the closure IL SMD, all I am getting. So IL is a key. When I am taking MS closure, I am going to get MS class link duration class ID. I am getting all. Means for both of them left hand side is super key. So therefore the relation is in BCNF, right? But it said clearly should not be in 3NF. If it is BCNF, it is also in 3NF. So that option B is incorrect, because it is BCNF means it is also 3NF. And 13% of the students also selected option B. So B is also wrong. And look for option C. 33% of the students selected option C. Okay, check option C is correct or not. I'll write with some dark color. And here class ID and mentor. Class ID and mentor. If I take a closure, so that is going to be a key. Class ID comma mentor closure. That is ID, mentor, link, subject. With the link we have duration. So I can call I and M is together is a key. So class ID and mentor together is a key. Remaining all are non-key attributes. Means class link is a non-key attribute. Duration is a non-key attribute. Non-key is called transitive dependence. If a transitive dependence is there, relation is in 2NF but not in 3NF. It is in 2NF because no partial dependencies, but not in 3NF. Okay, 2NF but not in 3NF. So answer is option C. C is the correct answer. Okay, check for last option D also, just for the reference. Last option D, class ID to class link. So by looking we can understand ID comma link is a key. If ID comma link is a key and here mentor to class link is there. So link can be replaced with mentor. So IM is also key. Here we have a two keys. When we have a two keys, we don't have part of key to non-key, but instead we have a prime attribute to prime attribute is there. We call it as a prime transitivity. Because prime transitivity is there, it is in 3NF. If it is in 3NF, it is also in 2NF. But it says in 2NF but not in 3NF. But it is already in 3NF. So that option D is also wrong. Okay. So instead of simply giving dependencies and to find what is a normal form, you may expect a question like this. That's what I am telling you. This time questions are not regular types. Questions will be slightly different. Okay. Is it okay? This yellow pen is not visible. So prime attribute to prime attribute I have written here. IL is a key, IM is a key. Okay, Rashi. Pradeep, once again option D. Arey Pradeep. So Q Pradeep. I'll go with this pen. So what is a key in the option D? I comma L, class ID and link. By looking we can understand. Because mentor is determining class link, link can be replaced with mentor. So IM is also a key. Means this relation is having two keys. So I, L, M are prime attributes. So M is a prime attribute. Here I have written prime attribute, and link is also prime attribute. So prime attribute to prime attribute is allowed in 3NF, okay, but not in BCNF. So it says it is in 3NF. But what is expecting? Question expecting it should not be in 3NF. But it is already in 3NF. So option D is wrong. Okay, Pradeep? Pradeep? Rashi? Okay? Oh, Abhishek. Please explain option C, Abhishek. Abhishek. Abhishek, simple. In option C, what is a key? Class ID and mentor is a key. Remaining attributes are non-keys. So class link to duration is non-key to non-key. Non-key to non-key is called transfer dependency. Transfer dependency means it is in 2NF but not in 3NF. Okay, Abhishek, got it sir, no needs. Badhiya yaar. No need. Done. Just one more question. Okay. Chalo, try this. You can expect a question on normal forms. Okay, I think it is simple. So, I am ending the poll and the majority students have selected option A. It might be correct. Now, what will be the key for this relation? Now, key for this relation is part number. If part number is a key and key with one attribute will not have partial dependencies, so that we can say that is in 2NF. Find which of the following statement is true about R. Okay, just let me do it in a more clear way. Which of the following dependency, like what is a key closure? What is a part number closure? Just checking the key. Part number closure is part number. Okay, I'll write with a coding because it is taking time and space. Part number, part description, part price, supplier ID, supplier address, NDPSA. Now, part number determining description and supplier ID determining supplier address, part number and supplier ID together determining part price. Part number N, okay, sorry, part number is N. Part number I am assuming as N. N is determining description. Supplier ID S is determining supplier address. Part number N and supplier ID S is determining part price P. Now, what is the key? DAP in the right hand side dependencies. DAP are the dependencies. Independent attributes are N and S. When you take the closure of independent attributes, NS closure is NSP. With N we have a D, with S we have a, all attributes. Now, what is the key? N and S. The key is N and S. If key is N and S, part number is part of key, is determining non-key. Part of key to non-key is called partial dependency. If partial dependency, it is 1NF but not in 2NF. So, what is the answer for this question? R is in 1NF only. Okay, that is selected by majority of the students. Almost 91% people have given right answer. And these are the similar type of questions. Okay, just look at this question. Slightly different. Okay, slightly different question. Just check and try to answer it. It is slightly different. Read the question carefully. I'll give a 1.5 minutes for this question. Read the question and answer it clearly. Right, understand, answer it. Look at in a relation whether, the relation name is whether, W, having country, city, day number, time, hours, probability of rain, probability of wind, probability of temperature. Temperature I am calling M. And country, city, day number uniquely identifies country, city T and day number D uniquely identifies probability of rain, probability of wind, probability of temperature. Temperature I am assumed as M. Okay, temperature M, wind, rain, hours, day number, city T, country C. Okay. Now this is one dependency, it is mentioned. Time hour, look at time hour I assumed as H is identified by day number. Okay, reverse. Time hour, just I am, look at how it is mentioned. Time hour H is identified by day number. What is the day number? D. Hours is identified by day number. Okay. And country is determined by, okay, so look at country is determined by, country determined by probability of rain and temperature. Rain R, temperature M. So Rm determining C. Okay, if weather has to be normalized to 2NF, okay, normalized to 2NF, which of the attributes will be present in both the decompositions of weather? Okay. So means if you decompose this weather table into 2NF, what is the common attribute you can expect? That is a question. If it is to be decomposed into 2NF means assuming it is already in 1NF, we have to decompose into 2NF. And do remember, questions not asked on decomposition so far. Now, what is the key for this relation? Now, undoubtedly, I can say CTD is a key, right? Because RWMHC, RWMHC are dependents. TD is independent, but when you take the closure of TD, you will get TDH, but not all attributes. CTD will be the key. When CTD will be the key, D is part of key and H is non-key, it is called partial dependency. So, because partial dependency 1NF, so now go with 2NF decomposition. How to decompose 2NF? Whichever is violating, that should be, whichever is violating the 2NF, that should be taken into separate table. Which is violating? D and H is violating. And D to H is a dependency, D is going to be a key. What are the remaining attributes? C, T, R, W, okay, R, W, M will be other attributes. And to make the decomposition lossless, this primary key should be taken as a foreign key. So, means what is a common here? D is a common. What is D? D for us is called day number. So, day number should be the common attribute when you decompose that weather table into two tables. Now, what is the common? D? D is a day number. Okay, 64% of the students have selected day number as the correct answer. Perfect. So, got it? Say instead of asking what is the normal form of the relation, this is a new way of asking questions. That is what I am predicting this year. Instead of asking conventional type of questions, definitely you may see a different way of asking questions. Okay, is it clear? Any doubt? Is it clear? Just I am ending the poll. Right. Before my explanation completes, 67% of the people given right answer. So, I will share the results if required. Okay. Done? Any doubt with this? If you have any doubt, just let me know. I will clarify you. If no doubt, I will go ahead with the next one. Yeah. That is about designing part of database. We have seen ER models, relational models, complete revision. Actually, this session is much helpful to you, so that because every topic is getting revised, ER models, relational models, functional dependencies, normalization, all topics are covered, and we have solved 1-1 questions. I think definitely this session will be helpful for you, right? Next is relational algebra. What you can expect in relational algebra? Undoubtedly it is very important, because so far from this chapter majority of the questions were asked. So, maximum number of questions asked is this chapter. No much concepts, but the way they have asked more number of questions on algebra. And calculus is less number, like on fingers we can count it, but algebra is very, very important. In relational algebra, you have a basic selection operator for selecting the rows. For selecting the columns, we have a pi, we call projection operator for selecting columns. And we have a set manipulation operators, union, intersection, difference are called set manipulation operators. And we had a manipulation, and it is an assumption that no duplicates, that is important. No duplicates in the output of relational algebra. No duplicates in the output of relational algebra. Then we have discussed about a cross product to compare the data between the two tables. We use a cross product, or we call Cartesian product. And also we have a joins. It is a join operator, and more questions asked on joins. And a join operator to combine the two tables. And next, division operator, this is also important, and these are the topics. But on basics only, multiple questions are combined, like if I want to say a question on foreign key, that I can frame with algebra. So that a foreign key constraint with algebra question combined to get a beautiful questions. Like this, there are multiple questions asked on algebra. So, more scope is there for getting more questions on algebra. So, this time I will expect minimum 2 questions from algebra, at least one 1 mark and one 2 mark questions. 2 questions from algebra I am expecting. This is my sense says. Okay. So, keenly I will discuss each of the topic with respect to one question, and more specifically, if you have any specific doubt, just post your doubt in the Q&A so that I can read and help you in that topic, okay, like what I have explained for the previous topics. Look at this question, which of the following relational operators will produce the following only, following tuples only. So, it is a questions on basic operators, and this is a tables are given, this is an output given. So, which algebra expression will give you this output? That is a question. Okay. Try this. I will give a poll for 1 minute. Now, 3y, 1y, 3y, 1y, this is required. Okay. QB1 union QB2. If you take the union, what you are going to get? 1x, like what you are going to get if you take union? 1x, 1y, 2y, 3y. 1x, 1y, 2y and 3y you are going to get. And QB2 union QB1 means same thing you are going to get, but Cartesian product results more tuples because it is a cross product. And here, because cross product, it results more tuples, because here more tuples are there, here also you will get more tuples, like 4 into 4, 16 combinations are possible, because it is also union, na? It is also will get 4 tuples like 3y, 1x, 1y, 2y. Cartesian product will results 16 tuples, but output is 1 tuple. So, option A is wrong. QB1 minus QB2 means it should be there in 1 but not 2, 1 but not 2. 1x is there in both of them, 2y is both of them, and 3y is there in 1 but not 2, 2 minus 1. What is 2 minus 1? It is there in 2 but not 1. In 2 but not 1, only 1y is there, but intersection will give you empty set. Here it results 16 tuples, it results empty set, but 1 tuple is there in the output. So, it is wrong. Okay. Now, QB1 intersection QB2. So, if you look for the common things, QB1 minus QB2, look at option C. That QB1 minus QB2 is 3y, QB2 minus QB1 is 1y, When you take the Cartesian product, 3y, 1y, you are going to get this one. That is an option C. So D is wrong. So correct answer is option C. Okay. Look for this question. Consider the following relations P of ABC, Q of ABC and R of BE, and the given instance, what is the number of tuples in the result of the relational algebra expression? So this kind of questions multiple times, many things are asked. Okay, this is one of the important questions for you. Just try for this question. Hope this slide is visible. If not visible, I will go with the next question. Yeah, Sridhar Kolli, union will eliminate the duplicates. It is a numerical answer type question. Answer here. Actually, I have seen personally, students are struggling when bigger expression is given, but you have to practice, no other option. Nothing was there in the question. P cross R, first table and last table, Cartesian product. What tuples to be selected? QD greater than 1. Okay. PQ, right? Sorry, P and Q. Fine. 1 minute. The P and Q, P cross Q, first table and second table. QD greater than 1. QD greater than 1 means the last tuple you ignore it. Remaining all are QD greater than 1. Okay. And one more condition is QB equal to PB. QB equal to PB. So B and B should match us. Right. 3 equal to 3, correct match. And 3 equal to 3, this is also correct match. And this 3 equal to 3, this 3 equal to 3. And this 4 had a match with this. And 5 does not have a match. These 3 are the matches. For these 3, we have to get A. What is the A? 1 and 2. What is the A? 1 and 2 is the output of this first query. When you look for the output of second query, look at the output of second query. Second query is P cross R. It means first and last. RE equal to 12. RE equal to 12 for these two tuples. And what is another condition? PB equal to RB. PB equal to RB. Now, what is this B9? Had any match? No match. And here 4 had any match? Yes. This 4 had a match with this. That is a match. Only one match is there. What it is selecting? Pi A. What is the A for this? 2. So means here the second query is giving answer 2. First query is giving answer 1, 2. Second query is giving 2. And between them we have a minus. Because between them we have a minus, 1, 2 minus 2 will give you 1. That's it. So what is given? What is the number of tuples in the result of the relational algebra expression? How many tuples are returned? Only 1 tuple is returned. This way questions are asked. Okay. Sakshi Gupta, tell me, what is your doubt? Okay. Is it clear? It is simple, and what little patience is required to solve in a proper way. Sir, in table PQ, common attributes are AB. Oh, very good Sakshi, hats off. But if अगर common attributes को देख रहे, इस condition का कुछ लेना देना नहीं है क्या? नहीं, common attributes यहाँ तो natural join नहीं कर रहे हम लोग कर रहे join based on a condition. वही condition को देखना पड़ेगा आपको, right? So ही अगर A B दोनों भी common है, कब कंसिडर करना? अगर नेचुरल जॉइन है तो कंसिडर करना. ये तो नेचुरल जॉइन नहीं है, क्या है? जॉइन विथ कंडीशन. इट इज अ कार्टेशियन प्रोडक्ट करके कंडीशन को एवेल्युएट करना, बस. ठीक है साक्षी?
Ronald, that is the same thing, but I just minimize that number of cases to check. Okay. PB equal to RB, 3 is also common. PB equal to RB, 3. Where is 3? But that 3 here, this is not correct combination na. When this is not correct combination, nothing to check. Anyhow, that is going to fail the condition. वो तो निकाल दिया, right? I just removed it. Okay, Karthik Chaudhary. Sakshi, अच्छा, okay sir, thank you, okay. Okay, done? Right. So there is a question on division operation. Look at this question. Now what is the division operation? Division operation, suppose A x comma y, B y. What is A division B will give you? X that matches for all y's. Suppose x1 y1 x1 y2 and x2 y1, y is y1 and y2. What it happens here, x1 is matching with both y1 and y2, so x1 in the output. x2 not in the output because it is matching only with y1 but not with the y2. So what is the answer for this question? x1. So means what division operation will do, if xy by y is there, it is going to find x for all y's. Based on that, there is a question. Just try and answer this question. Try and answer this question. Consider relation P of A, B, C, D and the given data instance. What is the result of relational algebra expression P division Q if Q is computed as? Now Q is computed from P. What it is selecting from P? It is selecting the tuple C greater than phi. Of the tuples, it is selecting BD. Then P division Q, ABCD by BD will give you AC. Anyhow, in the options it is mentioned AC. But which tuples should be there in the result? The tuples will decide the answer. Okay, good. Oh, that's quick. C greater than phi. Now, just I am looking for the Q. What is Q? BD. C greater than phi, C greater than phi, this one. BD is 5 2. And C greater than 5, that's it, only one, na? 3 2 1 1 3. So C greater than 5, only one. Now what is P division Q? P is ABCD division with BD will give you AC, which AC is matching with only phi 2 because only one is there. Here phi 2 in BD, here phi 2 in BD. So AC 1 3 is matching and phi 2 in BD, AC 2 6 also matching and phi 2 here, phi 2 and AC 1 1 is also matching. It is 2 phi, but phi 2 is expecting, it is 2 phi, not matches. So means what is the output? 1 3 2 6 1 1. 1 3 2 6 1 1, that is there with option D. So D is the correct answer for the question. Okay, this is how questions are asked on divisions and you have to solve that. Okay, that's about algebra, similar kind of questions. Okay, then we'll take a little break and after the break we'll continue with SQL and take a break for 25 minutes. So it is 11:45 and 12:10 I will be back. So after the break we'll continue with SQL, transactions, recovery, indexing and data warehousing. Okay, I'll brush up the things, fine. Right, when it comes to the SQL, undoubtedly SQL is very important. But only the thing I can say about SQL is practice, practice, practice. The more you practice, the better confidence you will get it. On SQL, when I have to talk about SQL, from SQL on basic questions and basic SQL queries, very rarely questions are asked, like maybe 1 mark questions. Like basics means like what are the types of operators we have. Like we have in, and, are, not, between, and, like, on this kind of operators, some basic questions. Very rarely asked, but it is not that completely it is not at all asked. So, some basic questions were asked. When you look for 2023 gate question on SQL, on a basic query is only SQL question asked, but that too 2 marks question asked. But that is funny on 2023 gate exam. But look at, you can expect questions on basic operators and like basic operators, set manipulation operators. What are set manipulation operators? Union, intersection and set difference. Set manipulation operators. And we know that set manipulation operators eliminate the duplicates, okay? And we have a questions on group by and having. Something 2 to 3 questions were asked on group by and having class. This is a bit interesting, sorry, bit more important. And then we have a questions on joins. Questions on joins. You will be given a tables of data and a join query is given and asked to find the output of the query. Joins. And more importantly, in this join, we have a outer join. More questions are asked on outer join and some questions are on self join. But self join not asked in the previous gate, it is expected. It is expected topic and outer join is important. And then after the outer join, the more important is subqueries. More questions asked on subqueries. And the subqueries, we have nested queries. So, means 90% of the chances are there to get a questions on subqueries. Nested queries, correlated subqueries and set comparison operators like any and all. Queries on any and all. Set comparison operators. These are the questions on subqueries. Nested, correlated, set comparison operators. Any, all. Fine. And apart from that, once a question asked on with class. But majority of the times questions are subclasses. The questions, subqueries, questions are of type, you will be given a tables of data and a query given and asked you to find the output of the query, that kind of questions. But even today, some of the students are calling me and saying that, sir, we are facing difficulty in subqueries. Yes, because it is a lack of practice. But only thing I can say, it is a practice. But the students are telling to me, सर अब जब बोलते समय आपको हमें आसानी लगा, बट अब करते समय थोड़ा डिफिकल्टी लग रही. थोड़ा डिफिकल्टी क्यों लग रही? क्योंकि प्रैक्टिस अच्छे से नहीं किया. ये एक है वजह. और दूसरा है, मे बी you haven't studied in B.Tech. These things means in that depth you might not study. But because you haven't studied, it means you have to do more practice. So that is only the solution. And for these SQL questions, what I suggest is, suppose you can able to solve it just by looking the question and with a little analysis. If you can able to do it immediately. Suppose if you can't able to do it immediately, I suggest you skip the question and do it in the second iteration or in the third iteration. But don't hold that question and waste most of time. So if you feel if it requires time to analyze the question, skip and do it in the second or third iteration. Okay. Right. Some basic questions on SQL. These are the basic questions on SQL. Possible scope is there for asking basic questions, at least for 1 mark. You can look for this question. Just try to answer it. So just I want to see what is a command over the basics. What is a command over the basics? Just I want to see. Just I am telling and people are putting same kind of things. Do you guys completed all the subjects? SQL queries, संस्कार SQL query solve करने में time ही ज़्यादा लगता है सर. Examples like supply, all red parts etc. हाँ संस्कार मैं यही बोल रहे, आपको ज़्यादा टाइम लग रहा है ना, आपको पहला इटरेशन में आपको सॉल्व करने का ज़रूरत नहीं है, क्योंकि जब ज़्यादा टाइम ले रहे और आपको सॉल्व नहीं हो पा रहे, उसका इफेक्ट इजी क्वेश्चंस पे ऊपर पड़ेगा. इसलिए आपको क्या करना, जो क्वेश्चंस वो डीबीएमएस भी हो कोई अदर सब्जेक्ट भी हो, इफ यू फील एनी क्वेश्चन it is taking time, I suggest you skip and go for the next question. Solve those questions in the second iteration or third iteration of the paper. ऐसा नहीं है तुरंत सॉल्व करने के बाद ही नेक्स्ट क्वेश्चन को जाना, ऐसा नहीं है ना. यू कैन check the questions like going back and forward. Okay, that's not a matter. संस्कार थोड़ा टाइम देना ही पड़ेगा, क्योंकि लाइक ज्यादा से ज्यादा स्टूडेंट्स ने ऐसा वाला क्वेश्चंस को छोड़ेगा, but we should not leave, never give up. Okay, but do it after some time, after easy questions are solved, all the easy questions are solved, then go ahead with the second iteration. Okay, done. This is 1 minute time. Count includes null values when it is applied on an attribute of a table. Is count is an aggregate function. Aggregate function ignores null values when it is applied on attribute of a table. It is going to ignores, but it is said includes. It is a false statement. Average includes null values. It's computation. Average is also aggregate function. We know the point. Aggregate functions will ignore the null values, will not consider the null values. Selection operation of a relational algebra is equivalent to select class of SQL. Select class of SQL to select the attributes or columns. Selection of attributes or columns is in algebra using pi, right? And but select operator in algebra is for condition selection. This is same as where. Actually, it is to confuse the students. Select, the students may confuse. So, it is also false statement. Means all the statements are false. Answer is option B. Oh, what you have selected? Option A. FFT. It is not true. It is false. Only 11 students, 18% of the students selected right. Selection operation of a relational algebra. In relational algebra, selection operation for writing the condition, something like A greater than B. Is select class of SQL is to select the columns. Both are not same. It is false. Have you observed? देखो, ये तो एक ट्रैप डाल दिया मैंने. यहाँ select दिया, यहाँ select दिया. So students are in a trap. Fine. Sir, try solving the questions using example, but still there is a problem on at least at most conditions. So English का grammar भी सीखना पड़ेगा राशि आपको. Where class is same. Done. Okay. चलो. When it comes to the set manipulation operators, what are the set manipulation operators? We have union, intersect, and except. And these set manipulation operators we can use between two instances R and S, if and only if R and S are compatible. When we can say the two instances are compatible? If both must have same number of attributes and the corresponding domains also should be same. Number of attributes should be same, domain names also should be same. Then we can call the instances are compatible, and moreover, this set manipulation operators eliminate the duplicates, because sets should not have duplicates. But in order to have duplicates, suppose I wanted duplicates also to be present in the output, then what we have to use? All. Union all we have to use, or intersect all we have to use. If you use all, it is going to retain the duplicates, otherwise duplicates are going to be eliminated. And scope is there for asking questions on set manipulations. Here, okay, that I cannot show in a single slide. Okay, look at the number of tuples. Number of tuples in the output of the above query. Number of tuples in the output of the above query. Sorry, in the below query. Okay, fine. In the below query. So my question is number of tuples in the output of the below query. Here it is used union all operator. As you know that union all is going to eliminate the, is going to retain the duplicates. There are two queries. This is the first query and this is the second query. Between the two queries, okay, up to this, order by is always at the end. Between the two queries, union all is there. Union all is there means duplicates are allowed in the output. Select consultation ID and patient ID from consultation. This is a consultation table. It requires to select consultation ID and patient ID, these two attributes to be selected. Where to care of consultation date is converted into month, and if the consultation month is February and if the fees is greater than 250, it is going to be selected. Now, what is the output of first query? Consultation ID and patient ID, right? And month consultation date should have February month, and it should be converted into month, and month should be February, and the fee should be greater than 250. Now look, consultation date, it is February and fees is greater than 250, wrong. It is February, greater than 250 is right. So what is a consultation ID and patient ID? 1003 and P903. 1003 and P903. And it is also February, but greater than 250 false because it is equals to 250. And it is February greater than 250, correct, and consultation ID and patient ID, that is 1007 and patient ID is P902. This is output of the first query. Because union all is there, now output of the second query also be in the output of the final output. So what it is selecting? Department should be GIN and fee should be less than or equal to 640. Department GIN, okay, here department GIN, fees is less than or equal to 640, same record 1003 and P903 is going to be duplicated because union all is there. Suppose only union is there, no duplicates. And department should be GIN and fee should be less than or equal to 640, this is also correct. So this 1006 and P902 in the output. So totally how many records? My question is number of tuples. There are 4 tuples in the output. But if here in the question, actually in the next slide, because I haven't shown in a single slide, so I said just how many tuples in the output. So it is order by 1 descending order. What is a 1? 1 is the first column in the output. What is the first column in the output? Consultation ID. So what could be the final output? It should be descending order of first column. Descending order of first column means consultation ID and patient ID. When you look at 1007 is a consultation ID, patient ID is P902, and 1006 and P902, and then we have a 1003 P903 and 1003 P903 will be the final output. And what is by order by 1? Order by 1 says sorting with respect to first column in the output in descending order. First column in the output is consultation ID in descending order. So 1007, 1006, 1003, 1003 will be in the final output. Here in this slide, I have options 1007, 1006, 1003, 1003 is matching with option C. Option A is wrong because it is not in the descending order of consultation ID. Option B is wrong because no duplicates of 1003 is shown, because the question is about union all operator and union all will retain the duplicates. Here also it is retaining the duplicates, but 1004 will not get. So D is wrong. Correct answer is option C. This way question is possible to be asked, okay, on set manipulation operators. Okay. I hope it is clear for you. And 4 tuples is given by Shravya, Tejanshu, Sakshi question mark, star she put, means no confidence. Okay. Right. Next important thing is group by and having. This is important, definitely I can say. Why? Because questions were asked on group by and having multiple times. What for group by? Group by to compute aggregate functions on group of rows. Compute aggregate functions on group of rows. What for having? Having is used to select the groups. For selection of a groups, we use having class. For computing aggregate functions, we use group by class, correct? And we have discussed certain points. The attributes of a select must be there in the group by class. If attribute is present in select but not in the group by, it is error. And what having class contains, either aggregate functions or grouping attribute should be present in the having class. Based on these points also questions are possible. And if you have a query using group by, the number of rows in the final output will be equals to number of groups. I think this point is very crucial, and based on this point I told you 2 questions were asked in 2015 and 16. I have shown you that questions when we have this topic of group by and having. And look at one question, at least you solve one question on group by and having. Set manipulation is over now, okay. So, okay, solve this question on group by and having. Consider the following table instructor table is there. Now, question is how many number of rows will be in the output after executing the below query. The question is number of rows in the output. The number of rows in the output of a group by query is based on the number of groups. Okay, just try to give an answer for this question. Take 1 minute of time and try to give an answer for this. Karthik Chaudhary, which question slide you want? Anyhow, these questions are going to be uploaded, right, for you? Don't worry. First, solve the question. And these things, what I am going to explain you, hopefully it will be shared in your, it will be uploaded in the portal so that it will be useful. Acha, set manipulation questions. You just check with that. Okay, Venkat Sai 1, Tejanshu 1, Sanket 2, Tejaswini 1, Sridhar 2, Shravya 2, Samata 2. Now 2 is going. Anurag true, Akshay Ganesh 1. Is it true or 1? What it is doing? Select instructor ID comma name from instructor where salary greater than 40,000. Group by instructor ID and name. First, where is to be executed? To select certain tuples whose salary is greater than 40,000. Salary greater than 40,000, true. This is false. True, true. This false because greater than 40,000 is equals to 40,000. So, how many true? 1, 2, 3 and 4 trues. And that selected tuples to be divided into groups, okay, according to what? Instructor ID and name. Instructor ID and name. Which tuples are selected? Lighting problem is more there. This one, third, fourth and last. Okay. Third, fourth and last. These tuples are salary greater than 40,000. Now, the selected tuples to be grouped according to the instructor ID and name. Instructor ID 1201, instructor name Alex, and these two records, this one and this one, together one group. This is second group, this is third group, okay. It is divided into three groups. Now, in the three groups, which group is to be selected? Having count of distinct university should be greater than 1. For the group, what is a distinct university? For this group, universities are same for the first group. That because distinct university is selected, having count of distinct university. Oh, sorry, it is not the third group. It is these two should form a one group, right? Because it is 1203 Mitchell, 1203 Mitchell. So, these two records will form one group, okay. These two will form one group, two groups. In the two groups, which group is to be selected? Distinct university greater than 1. For the first group, universities Harvard, distinct universities are Harvard 1, 1 greater than 1 is failed. So, first group will not be selected. For the second group, universities are Cambridge and Oxford. So, different universities. So, count will give you 2, 2 greater than 1 is true. So, this group is going to be selected, second group is going to be selected. How many groups are selected? One group. So, for that group, selected group, it is going to return one row in the output. So, what output it will give you? Instructor ID and name, that is 1203 and Mitchell, Mitchel in the output. So, the question is, the number of rows will be in the output of the following after executing the below query. How many rows it is returning? One row it is returning. And some people have selected 2, 2, 2, 2. But check it out where you have done a mistake. 2 is not the correct answer, okay. Right. Set manipulations we have discussed, okay. Next, we move to joins, okay. Next is joins. And what for join? Join requires a cross product. Because it is a query using joins, you may be given tables of data and a query may be given using joins, and very few times asked, but question is the above query returns so and so, the output will be the interpretations, English like statements, okay. But when comes to the joins, type of joins, we have outer joins. Questions were asked on outer joins. Outer joins we have left outer join, right outer join, full outer join. Outer join is going to return both matching rows and non-matching rows. And you will be given a tables of data and a query be given and ask you to find how many rows in the output of this outer join queries. That kind of questions were asked. Here, have a look. This is a slightly different question. Just I thought of showing you. Of what happened? Okay, that is a slightly different question. Could you please answer this question? Just read the question and try to understand on outer join. Just I will give a poll for this. I will give you 1 minute of time. Just 1 minute. Sridhar Kolli, sir, I have a class. Are you continue after 1 p.m.? I think actually it is scheduled up to 1:30 p.m. I'll continue up to 1:30. So, Anjali Paradesi, in that group, we have two distinct universities, so that group is selected. For one group, it is going to return one row in the output, Anjali. Okay, fine. So, it is more than 1 minute. I can stop the poll. Yeah, have a look. What is given? What majority goes? Majority goes to option D. Look at, consider two instances of the relation R1 and R2 with number of rows 10 and 8 respectively. The question is the minimum, not about maximum. The question is about minimum number of tuples in the result of the following query. What is the query? Select star from R1 natural full outer join. Okay. When it comes to the maximum, if assuming R1 and R2 does not have any attributes in common, it performs a cross product. So, 10 into 8, 80 combinations are possible. If there is no common attributes, the 80 will be the maximum. But question is about minimum. So, minimum means there will be a match. If there is a match, then will be a minimum possible, right? And because it is a natural join, so what is the possibility of matchings? The number of matchings, minimum matchings. For every row of R2, we have one row in R1. Because when I'm finding every row of R2, one matching row in R1, so there are 8 maps, 8 matchings are possible. If 8 matchings are there, it means in R1 we have 2 more tuples that does not have any matches, 2 non-matchings. That's it, na? Because it is a full outer join, will give you both matching and non-matching rows. So, totally how many is possible? 10 is possible. That is option C. Option C selected by very few students. Have you understood why option C is correct? Because it is minimum. Option D is correct in the case of maximum, because it performs a Cartesian product. If no common attribute, Cartesian product will give you 10 into 8, 80. That is the case of maximum. But question is about minimum. So, minimum will be the maximum of these two, simple. Maximum of these two, why? Because minimum definitely has a match and remaining assuming non-matches. So, 10 rows in the output. Is it clear? Next, we go ahead with the subqueries. In the subqueries, definitely I can say it is very important. We have a nested queries, correlated queries and set manipulation operators. In the nested query, first inner query is going to be evaluated. First inner query is going to be evaluated and the result of inner query should be given to outer query, right? So, means inner query is independently executed and the result is given to outer query. Based on the result of inner query, outer query will find the final output. So, evaluation is inner to outer or bottom to top. When it comes to the correlated subquery, this process is important to understand. According to the process, you evaluate the query, you will get the accurate answers. Query execution will start from outer, and for the row of outer, it is going to execute the inner query, but final output will be the tuple that is there in the outer query. It means the result of inner query will be given back to the outer query. Based on the result of inner query, outer query will be decided whether that outer query tuple to be considered for the final output or not. This is correlated query. In the correlated query, one of the important class is called exists class. What for exists? It means it requires to check whether result is there in the inner query or not. If you have a result, in the inner query, it returns true. Exists class if no results. If no result means empty set. it is going to return false. It means result not exist. So, questions were asked on exists, correlated query, nested queries, and more importantly nested queries, and next exists, then correlated query. These are the important topics from where questions were asked. Now, we will solve at least few questions on nested query. Okay, one question on nested. Just try for this, take 1 minute of time and try for this. Gattu Tejaswini, sir once explain full outer join. So, whatever it may be the joins, it should have matching rows. When it comes to the full outer join, which are not matched in the left side, which are not matched in the right side, both will be in the output. In the previous question, one table has 8 rows, another table has 10 rows. Okay, 8 is a minimum, na? Minimum anyhow matches because question asked about minimum. So, minimum match is occurred. Minimum 8 tuples match with one tuple. Every tuple match with one tuple in the art. So, 8 matches. So, remaining 2 left as a non-matching. So, that 8 plus 2, totally 10 is possible. Simply we can say in the case of minimum number possibility, maximum of these 2 tables. Okay, Gattu Tejaswini. Okay, what is the answer for the question? Gattu Tejaswini. Thank you, Tejaswini. Sridhar Kolli, MT. Okay, this is a numerical answer type question, na? Okay, you just put your answer in the webinar chat. Okay, it doesn't require a poll. Lakshman Chintala 0. What will be the question? What will be the output of the query? Question is output. Output, how 0 possible? Max of G1 price. It is a max of G1 price. Lakshman Chintala 0, null, Sridhar Kolli, MT, Sai Sri Kamal 1300. From the below table, gift ID, gift name, price, discount, availability. Select max of G1 price from gift G1 where 2 equal. Select count of distinct price from gift G2. Okay, this is question about correlated subquery. How correlated subquery to be identified? If the reference of outer query is gift G1 is used in the inner query. When the reference of outer query used in the inner query is executed for once for each row of outer query. But fortunately here, outer query use the same table, inner query also use the same table. Means for each record of gift, every record of gift again it is going to be verified. How? Look, select max of G1 price from gift G1 where 2 equal. What is finding in inner query? Count of distinct price from gift G2 where G1 price less than G2 price. Okay, G1 price less than G2 price. Here, this record is to be compared with every record of the same table. 500 less than 3550. This first record is true for this record 2, 3, 4, 5. Because G1 price less than G2 price. That 500 is less than with remaining 5 records. So that what is the count? It will give you count of distinct price. Count of distinct price is how many? 3550, 2000, 1500, 3000, 1300. Anyhow, all the prices are different. So it means that there is no meaning of distinct here because it is unnecessarily because no distinct prices are there. So how many count? What is the count? Count should be 4. Count is 4, but 2 equal to 4 is wrong. Because 2 equal to 4 is wrong, will this record will be considered for the output? No. For the second record. What is the price? 3550. What is expecting G1 price less than G2 price? 3550 is not less than with any other records. 3550 is not less than with any other record because this less than condition is failed. So, count will give you 0, 2 equal to 0 is wrong. It means this record also will not come in the output. When you look for this third record, 2000s, 2000s is less than 3550, okay, 2000 is less than 3000s, that is it, only 2 records. Are you getting my point? 2000 is less than with this record as well as this record. It is not less than with any other records. So, means what will be the count? 2, 2 equal to 2 is true, because it is true, this record is going to be selected. Fine. And when it comes to this 1500, G1 price less than G2 price, 1500 less than how many prices? 1500 less than 3550, 2000 and 3000s, means it is less than 3 records. Because it is less than 3 records, are you getting my point? Because it is less than 3 records, so count will give you 3, but 2 equal to 3 is wrong. So, this record will not be in the output. Okay. And when you look for 3000s, 3000s is less than with 3550, that is it now. 3000s is less than 3550 because G1 price less than G2 price. 3000s is less than with only 3550 but not with anyone else. So, that count will be 1, 2 equal to 1 is wrong. So, this record will not be in the output. Okay. And last one, this one, sorry, 1500, 3000s is not in the output. Last is 1300. 1300 is less than with 4 records. 1300 is less than with 4 records. Here count will give you 4. 2 equal to 4 is wrong. So, this record also will not be in the output. Correct? So, finally, only one record is selected. Which record is selected? G103. G103. And G103 had a price 2000s. That 2000 is less than with 2 other prices, that is 3550 and 3000s. So, that inner query is returned 2 and outer query is comparing 2 equal to 2, correct. It is correct only for this record because only one record is selected. In that it is selecting the max of price because only one record, that will be the maximum price. What will be the maximum price? 2000. Now, question is what will be the output of the above query, that is 2000. 2000 is the output of this query. Okay. Is it clear? Hello. Some of the students have selected 1300, MT. MT is not correct. So, what is correct answer? 2000 is the correct answer. Do you have any questions? Kontala Sai Vinay, 2000 is correct. Okay, Lakshman Chintala correct, Charita correct. Okay, is video getting buffered? Maybe for you, not for everyone. Okay, if it is clear, it is a correlated subquery. So, care should be taken to solve such questions. Okay, similar kind of questions. Next, we will go ahead with transaction management and concurrency control. In the transaction management and concurrency control, few questions were asked on recoverability and few questions on cascadeless schedules. Recoverability, cascadeless. Suppose if Ti and Tj are the two transactions, if I performed an update on some data Q and J reads that update before I commits, what this is called? Dirty read. This is called dirty read. If it is a dirty read, it is mean that J depends on I. Now, when J committed is important. If J commits before I, it is non-recoverability case. If J commits after I, because J depends on I, let I to commit first. Later, J should commit. If J commits after I, then it is called recoverable schedule. This point you have to focus. And if there is a dependency, means if there is a dirty read, we had a problem of cascading rollbacks. Based on this point, we have discussed multiple questions, and that could be easy to understand. And there is a questions in the previous gate also on dirty read and cascadeless schedules. Here you look at, this is one of the question for you to read and understand to answer the recoverability topic. Okay, try reading it, just I will give a poll for you, I will give you 2 minutes of time. Okay, 1 minute is sufficient, I hope so, because most of them I have answered. Look at, here it is a dirty read, simple, and 2 committed before this, it is not recoverable. And do you have any dirty reads? No dirty read, the schedule is recoverable, finish. Schedule 1 is not recoverable, schedule 2 is recoverable. Schedule 1 is not recoverable, but the schedule 2 is cascadeless schedule. Okay, why? Because no dirty read means it is cascadeless and also recoverable. That is perfect. That is an option C. That's simple, it's so simple. And these are the questions. And undoubtedly, more important is conflict serializability. What is a conflict serializability? What are the conflict operations? Read 1 of Q, write 2 of Q. Okay, just I, J I can say. Read write conflict. Write I of Q, read J of Q. Write read conflict. Write I of Q, write J of Q. Write write conflicts. If these conflicts are same in 2 schedules, then the 2 schedules are conflict equivalent. And assuming one schedule is concurrent schedule and another schedule is serial schedule and both are conflict equivalent, then this concurrent schedule is said to be conflict serializable schedule. How to check for conflict serializability? Conflict serializability is to be tested based on the precedence graph, correct? Means we have to draw the graph where each transaction should have one vertex. If there is a conflict from I to J, there is an H. If there is a conflict from J to I, that is also H. If there is a cycle, not CS. If there is a cycle, not CS. If no cycle, we can say that it is CS. Cycle, no cycle. That case we have to check. Is it has a cycle and no cycle? So I hope you know we have practiced enough number of questions on conflict serializability. Undoubtedly, it is very important, and damn sure you can expect a 2 marks question on this. Just solve at least one question. Just one question you write, solve. Consider the following schedule, S1 and S2, 2 schedules are given. The question is identify the schedules that are conflict serializable. Which schedules are conflict serializable is the question. Ronald Nichol, if there is no dirty read, there is a blind point. If there is no dirty read, it is directly cascadeless and recoverable. Okay? Ronald Nichol. better you can note that point. If there is no dirty read, it is cascadeless and recoverable. Ronald, okay. This kind of questions were asked. So, how to solve these questions? By drawing the graph. You have to draw the graph, precedence graph for both the schedules, and check is there any cycles in the graph. If cycles are there, we can say the schedule is not conflict serializable. If no cycles, we can say the schedule is conflict serializable. Okay, just 2 minutes is over for this question, that is maximum for any question. Okay. Now, how to solve this question? For S1, we have to draw the precedence graph. By looking, we can understand the subscripted number. There are two transactions, and what are the conflicts? Read X conflict with write X of other transaction, one conflict with 2. So, 1 to 2 is an edge. And write X, this is one conflict with read, already 1 to 2 there. And this is same transaction, not conflicts. And this is Y, no more conflicts. So, we can say S1 is CS. What about S2? We have a 2 transactions, 2 vertices. Read 1 X conflict with write 2 X, 1 to 2 is a conflict. Write 1 conflict with write 2. Read 2 X conflict with 2 to same, but this is a Y, no conflicts. I think it is also CS. It means both the schedules are conflict serializable. Answer is both. Okay, very good. Many students have given the right answer. Almost 79-80% of the students have answered correctly. Right? Next, when it comes to the recovery system, so far only 3 questions are asked on recovery system, and latestly in 2021 that 2 theoretical question asked. But still we have studied this chapter. But what I suggest is, because only 3 questions asked, if you have already studied this topic, don't give up, review it. If you haven't studied this topic, just I can suggest you can, if you haven't read it, you can ignore it. But I should not say you can ignore it, because we are aiming for IITs, and so that if to get IITs, we should get the top marks. To get top marks, we should not leave anything. But so far you haven't studied, then think about it. But you have studied, just go through the basic things. What I have go through my notes. Simply is to say, go through my notes. That is more than sufficient. Okay. Next, we'll go for indexing. In indexing, we have discussed various concepts. That beautiful concepts, and concepts are on concept oriented. Like questions are on concept oriented. It is not based on formula. On indexing, we have started with single level indexes. In single level index, we have primary, clustered, and secondary index. And primary index is created on primary key of the file, and the file should be ordered. Clustered index is created on non-key, but file should be ordered. And secondary index on candidate key or non-key, but file is unordered. But what is recommended? Recommended candidate key plus unordered on secondary index. And any of the single level indexes can be converted into multi-level index. And multi-level index can be implemented with tree structure called B tree and B plus tree structure. And when it comes to the B tree provides direct access. These are the important point I am just revising. And when it comes to the B plus tree, provides ordered access. It means B tree requires to search for the keys in levels by levels, and B plus tree will start from the root and come to the leaf, and it will go horizontally because all records are there in the leaf level, ordered access. And in both of them, the order of B tree and B plus tree is important. What is the order? I always suggested keep in mind what is the structure of a B tree node. B tree node should have n pointers and n minus 1, n pointers, n minus 1 key plus record pointers. N pointers, n block pointers and n minus 1 key and record pointers. When it comes to the B plus tree, because orders are important, very important, I can say, instead of important, I can say very important. And orders we have two things, again leaf node order, internal node order. What is there in the B plus tree leaf node? In the B plus tree leaf node, we have n key plus record pointers and 1 block pointer. That's it. 1 block pointer to point in the next node in the leaf level. When it comes to the internal node, n pointers are n block pointers and n minus 1 keys. N block pointers and n minus 1 keys. And undoubtedly, these orders are very important. I told you multiple times, remember the structure so that you can write formula, then and there only you can answer the questions, right? Look at this question on orders, because you can expect a question on orders, because question on orders is important. Solve this question and try to answer it. Haripriya, previous slide you want to take screenshot? Okay, Haripriya want to take screenshot. Haripriya, please take the screenshot. Just even I am moving aside. Haripriya taken? Okay, done. So this question I have given now for you to answer. Just I will give a poll for this. What are the orders of internal and leaf nodes of the B tree, B plus tree? Order of internal and leaf. Have you practiced those things? Order of internal node. Just now I told you, internal node will have n pointers. What is a block pointer size? Block pointer is 6. N minus 1 keys. What is a key field? 9 bytes. This total size should be less than or equal to block size. That's it. That is 6n plus 9n minus 9 less than or equal to 512. That is 15 and less than or equal to, when minus 9 goes to that side, plus 9, 521. So, n less than or equal to 521 by 15, which is less than or equal to 15 3s are 45, 71 means 34. This is internal node order. The question is about internal and leaf. First, internal 34, option A wrong, option C wrong. Okay, leaf we have to look. What a leaf node should contain, only that you remember, that thing you remember. What a leaf node contains? N key plus record pointers and 1 block pointer less than or equal to 512. That is 16 and less than or equal, when plus 6 goes to that side, minus 6, that is 506. N less than or equal to 506 by 16. So, we have to take the lower bound, okay, because less than or equal. So, 16 3s are 48, 26 means 31. So, leaf node will be 31. So, option D is wrong, option B is correct. This way you have to solve the questions. गर्व भंसाल, सर इंडेक्सिंग वाला क्वेश्चंस सॉल्व नहीं होते, व्हाट शुड आई डू? क्या करेगा, इंडेक्स क्वेश्चन सॉल्व नहीं हुए तो प्रैक्टिस करना पड़ेगा आपको, राइट? एटलीस्ट प्रैक्टिस दिस ऑर्डर्स कॉन्सेप्ट्स, सम एटलीस्ट क्लास नोट्स में मैंने जो भी पढ़ाया कम से कम उतना तो पढ़ के जाओ, अगर क्वेश्चन आए तो आप सॉल्व कर पाएगा, ठीक है? And view serializable, Gautam Reddy, view serializability question not asked. Okay, no. Shravya, view serializability questions are not asked so far, but I gave you some questions on view serializability. That type kind of questions you practice it. Because it is 1:30, I was given time till 1:30. What extent the best I can give you, I am giving you. Okay. And but still, if you have any problem, just you can feel free, you can call me after 8 p.m. or you can message me through my WhatsApp, so I can help you definitely. Okay. And Gaddam, sparse and dense short summary. And in dense, we have index record for every record in the data file. In sparse, we have only for some. Dense requires unordered file, sparse requires ordered file. Okay. Right. So my number is there with everyone, Harmeet Singh, but still I can share my number, don't worry. At the end of the session, I will share you. Harmeet. Next, you can expect a questions on B+3 deletion also. You can just have a look at this question on B+3 deletion. On B+3 deletion, have a look at this question on B+3 deletion. Just try to understand and answer the question. Try. Just give a try and don't give up. I'm saying you give a try, but don't give up. Ronald Nichol, scope of file management. That file management, you can expect the questions are of type you can expect questions on sparse and dense, but only exclusively file organization, you can't expect, you may expect a theory questions. Because file organization, the hierarchy I have explained, on that hierarchy you may expect a question, theory questions. Kamini Guruvardhan, Ipsha, Sakshi Gupta, okay, nice. Yes, okay, done. What is given if you delete keys 11, what is the impact on the below B plus tree? If you delete key 11, okay, where is key 11? Here also. And by looking what we understand, order is 1, 2, 3, 4, order is 4, order equal to 4 pointers. Minimum order is 50%, 2. Minimum order is 50%, 2 means 2 pointers. If 2 pointers, how many keys? 1 key. If 11 is deleted from this place and this place, we don't have any change in the leaf node because already it is having 1 key. But how do you manage this deletion? Because 11 is deleted even from the internal node. But you look at this tree, 11's right will have 11. It means this tree is satisfying a rule that left is less than right is greater than or equal to. So, but this node to point here in the place of 11, we should expect 1 key. What is expected? And whatever is there in the internal only copies, which copy we have to keep? The copy of 17 we have to keep here, right? And no more modifications are required. So, what options are given? A node with value 11 is deleted from only leaf. because only leaf it is incorrect. It should be deleted from leaf as well as internal. Node with value 11 is deleted from both leaf and internal. Yes, perfect. And no change is needed to the tree, but one change is required in the internal node. That's why it is incorrect. Node with value 11 is deleted from both leaf and internal node, and the value 17 will be merged with 9 and 10. But is 17 will be merged? No. Right. Merging is also one of the solution. Okay, we'll keep aside. Actually, merging is not required. Simply, we can keep a copy of 17 there. But if that option is there, we have to select it. If because that option is not there, we just will keep it. Because here one place is there, if you merge it, also will be the solution. That is called merging. But that is not required, but okay. Deleting the key value 11 is not possible, but it is possible. So that option D is wrong. What is left is option C. Instead of keeping a 17 copy here, even this 17 if it is merged here, that is also a solution. That is also a solution. Okay. So the perfect answer for this question is option C. And okay, in data warehousing, actually data warehousing was added, sorry, data warehousing is there in a DA paper, not in CS paper. In DA paper, data warehousing, because DA paper, as you know that it is started in 2024 and only one paper happened. Last year I was keep on telling to my students, in data warehouse, because data warehouse is completely theoretical concepts, okay. So I said to my students, last year I was keep on telling that they can expect a question on data normalization. And data normalization, we have three topics: min-max normalization, z-score normalization, normalization by decimal scaling. Okay. So I was told to my students in the last year, you can expect a question on data normalization. Only one question came from data normalization in 2024, that too on z-score normalization. That is simple. You can apply values in the formula, you can get the answer, numerical type. And this time, I was keep on telling to the students while I am taking the classes, here this time you can expect a question on OLAP operations. What are the OLAP operations? Slice, dice, roll up, roll down, like those are the pivot operations. 5 operations I told you, those are the possible things in data warehouse. And I have given almost nearly 100 expected type of questions. And I suggest you just go through those expected type of questions, that will be sufficient. Okay. And here is one question for you. Do you remember the data warehousing concepts? It is only for DA. Now CS people, you can go for a lunch also. Suppose you are writing CS also, happy. You are writing DA, just listen to me. At least these questions what I am making you solve, that will be good. And but please listen to me, I will take hardly 5 minutes and don't go away, all of you. Please be on the session. Pradeep, just be on the session. I want to conclude in 2 to 3 minutes. Suppose that minimum and maximum values for the attribute income is 12,000 and 98,000 respectively. We would like to map income to the range 0 to 1.0 by min-max normalization. What is the value of 73,600? So how to calculate the new value? The 73,600 minus minimum value 12,000 by maximum value 98,000 minus minimum value 12,000 into new max minus new min, that is 1 minus 0 1 plus minimum 0. So it will be the, when in the case of 0 to 1, this will be the value. Okay. And this is a different kind of questions. Now, as I told you, if it is 1 mark question on OLAP operation, you can expect it. It is a MSQ kind of question. Which of the following operations can be performed on data cube? What are the OLAP operations performed on data cube? Slice, dice, roll up, but it is not normalized. So, what is the answer for these questions? A, B and D. Okay. And always I am yours Ramesh Masuna signing off. We will meet one more time with compiler design revision session. And if you have any specific things, let me know in advance so that those things I will discuss in the revision session. Okay. Fine. Thank you one and all. Bye bye. See you. Good day. Thank you.